Hey guys, welcome to the live. We're going to start in about a minute. So today we are going to do our final live for exam season 2025. So I'm going to finish off by doing the 2022 stats paper full, and then we're going to do the 2022 mechanics paper full. In my opinion, these papers have some interesting questions. They're not too bad, but they'll be good practice for the exam tomorrow. So I'll give you some exam advice, how to tackle different types of questions, how to overcome challenges if you face them, and how to maximize your marks. So I'm gonna jump right into it in a few seconds. But yeah, hope all your exams so far have gone well. I think you guys had computing and physics recently, so hopefully that went well for those of you who did those. But yeah, all right, cool. I'm so cooked. Don't worry, SIM card 707. We're gonna do this. All right, we're gonna cook in the exams, guys. So let's start and get right into it. Question one: George throws a ball at a target 15 times. So that is n. Let me just make my pen thinner. Each time George throws the ball, the probability of the ball hitting the target is 0.48. So that means he could either hit it or miss it. So there are two outcomes. So we're thinking binomial distribution. The random variable x represents the number of times George hits the target in 15 throws. Find these two probabilities. So the first thing you have to do is define the variable. So they've defined the variable up here, but we need the model. So x is going to be binomially distributed. Notice they didn't tell us. We have to infer that. There are 15 trials, and what is the possibility of success? 0.48. Then I just need to find part one, probability that x is equal to 3. So in my calculator, I go into the probability distribution mode, binomial PD. Then in my variable, I will write 3, 15, and 0.48. And I get 0.01966 and so on, which is equal to 0.0197 to 4 decimal places. When I'm doing the questions, I like to give a more full answer in my intermediate state of working and then round at the end, just so they can see my full answer in case I make a dumb rounding mistake. They can see I did the correct method overall. All right, so that's how you do part one. Let me know if you do want me to show my calculator for these things. I'll be happy to. Got it right here, but yeah, that's how you do that. Part two, the probability that x is greater than or equal to 5. So when you're doing binomial continuous distributions, you need a less than or equal to sign. So if it's greater than or equal to 5, that's the same as saying the probability is 1 minus p is x is less than or equal to 4, because we don't want values that are 4 or less. We want 5 or greater. If we look at a number line, just for reference, you've got 4, 5, and 6. So we want these values. So we're going to take away the remaining points. So that is just going to be equal to 1 minus 0.0798 and so on. Then you can save this, store this in your calculator as A. So you can just have it for future reference. And when you subtract that, you get 0.920124 decimal places for part 2. All right. Hopefully your internet gets better, Bryn. All right, is this making sense so far? Let me know if you guys have any questions. For part B, that's a year 2 type question. So now George throws the ball at the target 250 times. Don't we have to write the whole number? You don't need to write the whole number. You're allowed to round them. I like to round to 4 decimal places, but it's probabilities, so you'll be writing long, long, long things. Here, just write to 4 decimal places as a rule of thumb, all right? So for part B, he's throwing it at the target 250 times. Kind of sad, but that's going to be my end value, okay? You're going to see people doing a bunch of weird things in stats, like flipping a coin 600 times a day. I kid you not. Use a normal approximation to calculate the probability that he will hit the target more than 110 times. So that's looking something like that, right? The reason we can do the normal approximation, I like what I'm seeing, NP and 1 minus P. Awesome. The normal approximation, why does it work here? Well, because n is large and p, which is 0.48, is close to 0.5. Hence, we can use a normal approximation to the binomial distribution. So we need to define a new variable for the normal distribution. So I'm going to just say that y is the number of times he hits the target, and that is going to have a normal distribution. The parameters, we remember, are mu and sigma squared. How do I find these? We have to get mu is equal to np. That's the mean number of times, right? So that's just how many times you do it times the probability. So that's 250 times by 0.48, which is equal to 120. And the standard deviation is the square root of np1 minus p, which is equal to the square root of 120 multiplied by 1 minus 0.48. And we get that is 2 square root of 390 over 5. So if you square that to get sigma squared, you get 62.4. So that means that y is going to be normally distributed with 120 and 62.4. So these are our parameters. Yep, the variance is 62.4. So now, have I answered the question yet? Not yet. I just need to find the probability he will hit the target more than 110 times. So in terms of x, the probability that x is greater than 110 if I'm doing a binomial distribution, we need to remember to do a continuity correction. This is super important when using binomial approximations because we're going from a discrete distribution, which is binomial, to a continuous. So this would be the probability that y is greater than 110.5. And I'm going to explain this using a number line again, just in case you don't understand. So there's my straight number line. I'm going to write down 109, 110, 111, and so on. So I need the probability that x is greater than 110, right? So that's going to be greater than or equal to 111. That is for a discrete distribution. However, y is normally distributed, and that is continuous. So continuous can take any range of numbers, even in between these. So what number rounds to upwards to 111? It would be 110.5. That's the maximum furthest down we can go. So if we're continuous, this is what it is. So either you'll go 0.5 above or 0.5 below your value, depending on if you want to include it or not. Here, you are not including 110, so you're going to go 0.5 above 110 to get that. So then in your calculator, if you put in 110.5 as your lower limit for a normal distribution and your parameters as these, you get 0.8854 to 4 decimal places. And that is how you would do this type of question. Yep, sure. I'll show you how to use the calculator for this. So in your calculator, I've got this white one. So you go into menu and you want to go into the statistics distribution. So now this is a cumulative distribution and normal. So you go into 2. The lower bound is going to be equal to what? 110.5 because we want greater than that value, right? And remember, with normal distributions, you don't care about the equals to sign. The upper bound is going to be really, really big. So just type in 9 a bunch of times. Just spam it in your calculator. All right. What is my sigma value going to be? That's going to be the square root of 62.4 because that is sigma squared. Remember, 62.4 square rooted. Close your brackets just in case. And then my mu value is going to be 120 equals, and then I get 0.8854. Which is the answer I have there. How do you know which upper is lower? How do I know which is upper and lower? Here, I want to go above 110.5, right? So if I just draw my normal distribution for that, the mean is 120, right? 120. I want y greater than 110.5. So 110 would be here, right? 110.5. So I want this probability here. So this is going to be my lower value, right? Because I don't want anything below that. So this, my upper value is going to be like almost infinite because it asymptotes, right? So you can see that this probability has got to be greater than 0.5. I get an answer of 0.88, so on. So this answer makes sense. So that is what I'd recommend you to do. Draw the diagram. It takes no longer than 2 seconds just to see the probabilities you're expecting and if your answer makes sense. All right, this is my number one tip for normal distributions if you're completely lost. Draw the diagram. It is going to help you a lot. Can stats go away? Oh, I wish. All right, so how does this question look so far? Is it making sense, everyone? So yeah, they've combined a binomial question with a normal distribution question straight away, but we should be good for that. Awesome. I'm going to move on to question two. Question two is quite a long question. I did it a long way. There are definitely quick ways. Oh, no worries, Simcard. I'm glad it's helping. Do you think this paper will be like our one? This is a 2022 paper, so it's 3 years ago. So you may find some similarities. Have you got any general stats tips? Yeah, I'm going to give the stats tips throughout for each of the questions. Then at the end of the stats paper, remind me and I'll tell you my general advice for stats. And then we'll do the same for mechanics, all right? So this question is quite long, in my opinion, and I did it a long way. There are shortcuts, but I'm going to break it down just so everyone can understand, all right? A manufacturer uses a machine to make metal rods. The length of a metal rod, L centimeters, is normally distributed with, one second, normally distributed with a mean of 8 centimeters, so that's going to be mu, and a standard deviation of x centimeters, so that is going to be sigma. Given that the proportion of metal rods less than 7.902 centimeters in length is 2.5%, show that x is 0.05 to 2 dp. In other words, find the standard deviation. So the way you have to do this, remember, if you're finding mu or sigma, I'm going to make the note here, finding mu or sigma, you have to use the standard normal to work it out, all right? So if I put this sentence here into a mathematical notation, that is the proportion is P of the length being less than 7.902. What is the probability of that? They tell me it's 0.025. So we need to find sigma, so using the standard normal, and I always draw a diagram for this. It is super helpful to help me map my x and z values here. So for my L here, the mean of L they've given me is 8 centimeters. For Z, the mean of Z we know is 0. The probability that L is less than that is 2.5%. So let's say that this is 2.5%, and the L value is 7.902. I need to solve my Z value. The formula, which you need to remember, guys, is Z equals X, but in this case, X is L, minus the mean divided by sigma. That's not given on the sheet, I believe. I'm not sure, but just memorize that. Nice little formula there. So I don't know what Z is, but I know L is that. I know what mu is, but I need to solve for that. So how am I going to find my Z value? There are two ways I could do this. I can use my calculator and do the inverse normal for the Z. Oh, it's in the booklet? Awesome, that's great then. It's given, but it's in a weird format. Yep, inverse normal. So in my calculator, I'm going to go on to the same thing, go into inverse normal. The area I want, and remember this is less than or equal to, is 0.025. That's the area I want. My standard deviation is going to be 1, and my mean is going to be equal to 0. I get the value of Z is this, negative 1.9599, and so on. So that is one way of doing it. You can also use the table, and I'm going to show you how to use the table in the booklet now as well. So you'll go down, and it's a small table on the book here. But what you need to know is this thing here. This is very important. This is doing the greater than bit, which is annoying, but you should know that for the standard normal, it's symmetrical. So you just change the sign. So the probability I want is 2.5%, which is this. So if Z is greater than 1.96, you have 2.5%. So that looks like 1.96. This is 2.5%, which means that if Z is less than negative 1.96, you also get 2.5%. So that is how we figure out our Z value using either the calculator or the table in the book. So I'm going to use the one in the book because you can use that. So that's negative 1.96 for Z. What is the length corresponding there? 1.96. 7.902. My mean is 8, and my standard deviation, they call it X. So we will call it X as well. If I rearrange, I get X is equal to, that subtracted is minus 0.098 divided by minus 1.96. And that gives me a value of 0.05, which I have expected. So yeah, the easier way to do it is using the calculator. But what I recommend you guys to do in the exam, use the calculator and use the table if you're good at both. Try and get good at both just so you can verify your answer. You know, it's good to see that it's correct, but also they've given you the answer here, so you'll know you'll be correct. Okay, part B is a longer question. calculate the, sorry, not part B. Part B is shortest question here. Calculate the proportion of metal rods between these two lengths in length. So part B, that's just normal distribution type question. So the probability that is between 7.94 and 8.09, these are the lengths given in the question. If I put that into the calculator, I get 0.8490 to 4 decimal places. What I have put into my calculator, the lower bound is 7.94. The upper bound is 8.04. My mean value is going to be x, and my standard deviation is going to be 0.05. That is what you put in your calculator to get this probability for part B. Is this making sense, everyone? So part C is going to be the long question. So the only reason they've made it like it could be a bit difficult is because it's a lot of words, but if you actually understand what's happening, it's not too bad. So the cost, and they put it in bold, of producing a single metal rod is 20p. A metal rod where the length is less than 7.94 is sold for 5p. If it's between these lengths, it's sold for 50p. And if it's greater than 8.09, it's shortened for an extra cost of 10p, but then sold for 50p. Calculate the expected profit per 500 of the metal rods. Give your answer to the nearest pound. Straight away, in this question, I'm writing at the top, nearest pound, just so I remember. I don't want to lose the dumb mark at the end, all right? So what am I going to do in this type of question? First, I'm going to evaluate how much money they're losing or gaining from each of these. So the cost, that's just going to be minus 0.2 because that's taking away 20p. Sold means you gain 5p, so that's plus 0.05. Sold for 50p is plus 0.5. Here, it's a cost of 10p, but then sold for 50p, so that's minus 0.1 plus 0.5. You have a gain of 0.4. So we can see how much money you make for each of these sections. Here, they're all earnings, and you can see the cost of producing a single rod. So what I'm going to do first is find, and I'm going to write this out all, find the probabilities of each length occurring, okay? So the probability that L is less than 7.94, that's the first section. In my calculator, I'll put 7.94 as my upper bound and negative 9999999 for my lower bound with the same sigma and mu values, and I get 0.1150 and so on. Now, you're going to have a bunch of these probabilities. You need to store these values to make it so much easier, okay? So in your calculator, you press the store button, which I think is just above the 7, and press any of the buttons with a small red letter on it. So you can press A. So I'm going to store this as A. Then the probability that is between 7.94 and 8.09, which we found up here, is 0.8490 and so on. Store that in B. Then the last one is the probability is greater than 8.09 is going to be equal to 0.0359 and store that in C. All right. So these are the probabilities that a rod is going to come out as this length. So I have got to find for 500. So first I'm going to say the cost of making, that's the ice cream van outside. The cost of making 500 is just 500 multiplied by, well, what did they say the cost was up here? 20p. So that's 500 times by 0.2, which is nice 100 pounds. So it costs 100 pounds to make 500 rods. Now, I need to find the how many I earn from each of these lengths. So earning, and the reason I know they're all earnings is because I calculated they're all positive at the start. So earning from each length, each L, the formula I'm going to use is the earning is going to be equal to 500 multiplied by the probability. This is telling me how many rods there are in each group, right? From a sample of 500. And I'm multiplying that by the sell price. I just call it sell price, by how much I'm selling it for, right? That's going to be my earning. So for each of them, if L is less than 7.94, that's going to be 500 multiplied by my A value. In your exam, write out this thing with the dot dot dots. I would recommend doing that. But in your calculator, put in A, multiplied by how much are you earning for these ones? 5p. So that's multiplied by 0.05, and we get 2.876 and so on Store that in D. You've got a lot of things being stored in this one. What am I putting in to find the probability in my calculator again? In your calculator, you go into the normal distribution, you go into normal CD, which is 2, and then you put in your lower upper limits, and then your sigma and mu, which are given in the question. Then I'm going to do the same for the other two. So if it's 7.94, L 8.09, you do the same thing. So 500 multiplied by its probability, which is B, times by how much you earn. That was 50p. We get 212.25 and so on. That is going to be stored as E in my calculator. Then L is greater than that. You have 500 times by C times by how much are you earning here? 0.4 we figured is 7.186 and so on. That's going to be stored as F. Now the total earnings is going to just be equal to D plus E plus F, which is going to be equal to 222.312 and so on. Make sure you use this full answer. And they wanted the profit. To find the profit, that's how much you earn after giving up money. So that is in layman's terms. So that is earnings minus cost. So that is 222.312 so on minus the cost, which was 100. That is going to be equal to 122 pounds to the nearest pound. And that is how you do part C. Does this make sense? It's not too bad of a question if you understand how to approach it, and just break it up. See, just work on what you know and build a story from there. Does anyone have any questions for this? In the chat, let me know. So yeah, that's how you do part C. It's an annoying ice cream fan. All right, cool. Next part of the question. The same manufacturer makes metal hinges in large batches. Okay, so now we're not talking about rods, hinges. Completely different part of the question. This is like subtle foreshadowing for mechanics, rods and hinges. The hinges have a probability of 0.015 of having a fault. A random sample of 200 hinges, so that's N, that's P, is taken from each batch, and the batch is accepted if fewer than 6 hinges are faulty. So I'm just going to write less than 6. The manufacturer wants 95% of the batches to be accepted. Explain whether the manufacturer is likely to achieve this claim. Thank you so much for all the gifts, guys. I really appreciate all the support. Awesome. So for this part, I need to define my variable. So what type of distribution do you guys think we're going to be using here? Let me know in the chat. What sort of distribution is part D focusing on? So this is going to be a binomial distribution question. Awesome. Yep, binomial. Why? Because if it either has a fault or it doesn't. Exactly, binomial. The word binomial, bi means 2. If there are only 2 outcomes, it's going to be binomial. You've only got 3 main types of distribution you know. You've got binomial and normal, and the other one is just like an equal distribution. So for this one, there are only 2 possible outcomes. There's not multiple outcomes with an equal chance, because that is not equal to the outcome of a non-fault. So it's going to be binomial. That's your trick of remembering them, all right? And if it's something measured along with many values, it's going to be continuous. So for D, I'm going to first, remember, define the variable. In every single question, if it is not defined, define it. Because sometimes they'll give you the mark, sometimes they won't. So I'm going to call my variable X is the number of faulty hinges in a batch of 200. I've been as specific as I can for that. This one is not going to, this is not a hypothesis test actually. So it's not going to be two-tailed or one-tailed. You'll see why we don't need to do a hypothesis test here. So X is going to be binomially distributed with N is 200. The probability of a fault, they told us, was 0.015. Pretty good chance, it seems. So I need to find what in the question? The probability that fewer than 6 hinges are faulty. Exactly, it asks for probability. So I'm going to accept if less than 6 are faulty. So the probability that X is less than 6, well, we know we have to have a less than or equal to sign. So that's the probability X is less than or equal to 5. I hate saying probability so fast, such an annoying word. So if you put this in your calculator for a binomial distribution, you get 0.9176. So the probability that less than 6 are faulty is 91.76%. So this means that, I'm going to write this out here for you guys, 91.76% of the batches are accepted, right? Because this is a probability that a batch has less than 6 faults. So this means that what does the manufacturer want? He wants to accept 95% of the batches. But here, only 91.6% of the batches are accepted. So, unfortunately for the manufacturer is unlikely to achieve their aim. Why? Because, and you need to just state this, 0.9176 is less than 0.95. In a probability type question, just always state a relationship using inequality signs, quality signs for your reasoning, because that is going to be a mark in itself. So this is what you do. So you can see, we're going to accept if less than 6 are faulty. So, okay, find the probability that X is less than 6. Well, 91.76% of the batches will be accepted. He wants to accept 95%. He unfortunately does not meet his aim. All right. So, awesome, guys. Does this question make sense? So question 1 and 2 kind of go hand in hand. 1 starts off binomial, then goes normal. Then 2 starts normal and goes binomial. So you don't need to deal with any of these type of distributions anymore in this paper. All right. I just passed the thing. Yeah, very nice question. All right. Hopefully you guys get good questions where you're just doing probability work, like nice simple ones. But yeah, that's question 2. We are gonna swiftly move on to question 3. By the way, make sure you take note of some of these important points or remember them for your exam. Like these things, like if you just say this and put your conclusion, but you don't compare them, you're not gonna get the mark, even though it's quite obvious that 91.76 is less than. You need to say it. Sorry, I saw something. Can you go to the working for B again real quick, please? Yeah, sure. If you want to take a B again, is just here. This is what I put into my calculator. I don't know if you meant B or C, so I'll show both. If you want to take a screenshot, the 5 marks, yeah, C. So, if you want to take a screenshot of this, so you can refer to it later. Hopefully it's legible. Yeah, I think it's legible. All right. Cool. We are going to move on to question 3. No worries. Question 3. Everyone's favorite question. The large data set question. That was sarcasm, by the way. Diane uses the large data set to investigate the daily total rainfall for Camborne. So we're thinking the UK and Camborne. Which part of England is it in? Is it in the north or south, guys, of the UK? Do you think sample mean hypothesis testing will come up? I have a feeling it might. I don't know. I just have a gut feeling they'll include that, which is why the last video I posted, guys, about the viral kunafa pista is about that. Sample means for hypothesis. South. Yes. This is the reason I won't get 100. Yeah. Camborne is in the south, and we're going to come to that further in the later part. I'm going to show you about that large data set nonsense stuff. So Camborne, which you guys rightly said, is in the south. So write down how a value of 0 to 0.05 is recorded in the large data set. I posted a video for this doing this pretty much exact type question. Do you guys want to have a go? Tell me what this value is recorded as in the large data set. We should recognize it straight away. Trace. Yes, exactly. So this is how it's recorded in the columns as a TR, but they allow you to write it with a capital. They allow you to say trace, or they allow you to say trace with the capital. But this is how it's recorded, so just note that. All right. So TR. Diane uses the data for the 31 days of August in 2015 for Camborne and calculates the following statistics. So n is given, the sum of r is given, and the sum of r squared is given. Use these stats to calculate the mean in August 2015. So this question should be a blessing. When you have large data set questions, most of the time I've seen, they ask you to find the mean and the standard deviation. Those are a free 3 marks or however many marks they want to give you. It is easy marks, which I know everyone can get, so don't mess that bit up. So if I want to find the mean rainfall, that is going to be equal to the sum of the rainfalls divided by n, which is just simply 174.9 divided by 31, and you get 5.64 millimeters to 3 significant figures. I've rounded there, but yeah. What I recommend is you put in your intermediate number, so 5.641 and so on, and then you round, just so they can see how you rounded. All right, part 2, find the standard deviation for the daily total rainfall. So the standard deviation of R, that's what that notation says, is equal to, write the formula down, which is given in the formula booklet like this, but it's given with an X instead. So that is going to be equal to, and just sub in, 3523.283. The hard part is not writing the wrong number here. So make sure you write the correct number, guys. Divided by 31 minus, and I'm going to use my exact answer here, 174.9 over 31 squared. Do not use your rounded answer for the mean in this working. So then you get 9.045 and so on, which is equal to 9.05 millimeters to 3 significant figures. So yeah, 3 marks. Hopefully you guys, need that type of question. Hopefully you guys get this type of question for part B. But part C actually is not too bad for a large data set type question if you know your geography of the UK. Diane believes that the daily total rainfall in August is less in the south than the north of the UK. So we're thinking of our geography and where the locations are located. The mean daily total rainfall in Luchars, so this is a different place, for August 2015 is 1.72 millimeters to 2 dp. State giving a reason whether this provides evidence to support his belief, and we have to give a reason for 2 marks. So, remember I asked you guys at the start, where is Camborne located in the UK? You guys said it's the south. So that means that you guys could infer that Luchars is most likely going to be in the north. So I'm going to show you my beautiful drawing of the UK. Wow, look at that. And you got Ireland there. That is the UK. So Luchars is going to be up here, and Camborne is down here. So Camborne is in the south and Luchars is in the north. I'm going to show you where the other locations are in the UK just for reference so you can remember them. That's Leeming. Heather's about here, like near London. I know that that is not near, like it's about there, but still, it's fine. And Herne is down there. So these are the UK locations you need to know. So the rainfall in Camborne, what did we find was 5.64. 5.64 millimeters. And in Luchars, Diane finds is 1.72 millimeters. Now, we just need to look at his assumption. So, you really drew Italy, but it's fine, it's fine. All right, this is A-level math statistics, Sadiq. So, here, his assumption is that rainfall is less in the south than in the north. Well, here, rainfall is more in the south than in the north. So we just need to say, Luchars, just state where they are. You've drawn your map, just write them in words. Luchars is in the north, and Camborne is in the south. But the mean rainfall is higher in Camborne, which is in the south, compared to Luchars, which is in the north. Therefore, there is no evidence to support Diane's belief. Okay, this is how you would have to say this type of question. You have to compare it, this bit here. The mean is higher in Camborne in the south compared to Luchars in the north. You cannot make an overall assumption about the UK. Why are you lying? This is religious. You cannot make an overall assumption and just say the mean rainfall is higher in the south than in the north. No, it's higher in Camborne, which is in the south, compared to Luchars, which is in the north. Therefore, there's no evidence to support Diane's belief because he believes it's higher, he believes it's less in the south than in the north. So that is how you do it. Guys, what are you saying? This is clearly food tech, honestly. So, I hope you enjoyed my little geography lesson. That's a map of the UK, apparently. But yeah, going back up to the question. Are there any more parts we need to do? The Scottish Rebels and Macbeth. All right. The Diane uses the LDS to estimate the proportion of days with no rain in Camborne in 1987 to be 0.27 to 2 dp. Explain why the distribution binomially 14 and 0.27 might not be reasonable model for the number of days without rain for a 14-day summer event. It looks more like Italy. I know, guys, stop making. I know it looks like Italy, but it's okay. You guys get the point. This is the UK now. This is not Italy anymore. All right. So, what do you guys think is the answer to why it's not a good model? It's not symmetrical. Let me just have a think. What do you mean by that? I have a feeling I know what you're trying to say, but you're not using the correct word for the mark scheme. It's upside down Africa. Guys, stop butchering this drawing. Oh man, it's the fact that I can actually see it. Most days are trace days. You can't really say that because you don't 100% know that those 14 days he picks are trace. It's too far back. Nope, it's not. It's not about it being too far back. We've got the data, right? I see the correct answer. Scott Gregg said probability is not fixed in real life. AQA response. Yes. Elephant ear upside down. All right, guys. This is the main thing you're taking away from my life. The probability each day isn't constant. Exactly, Freya. It changes over time. Nice question mark. So that is what you say. Because I made a video, guys, about binomial conditions. Remember the 4 conditions for binomial model? Just looking at what a model looks like is the number of trials or days is fixed. The probability is fixed. There are 2 outcomes and they're independent. Well, the days can be fixed, 14 days, you pick 14 days. However, the probability is not going to be fixed. He's assuming that the probability is fixed at 0.7, which is unlikely the case. So what I would write is, he's assuming, and I'm also assuming, he's assuming the probability of no rain, which is P, stays constant or is fixed at P equals 0.27. But I need to say, why is that not a good model, right? But in reality, so we have to bring this back to real terms. In reality, it's unlikely to be constant. All right, so that's what you would say for this one. Other answers you guys can say are so yeah, think binomial conditions. Go back to the video. They need to be independent. The 14 days that they're picking are unlikely to be independent of each other, right? Because one day could have an effect on the other, right? So let's say you have a massive storm going on. The storm from one day could continue on to the next day, or so on. And also the probability of rain is not constant. They can also say that. All right, especially with weather to UK, definitely not fixed. Exactly. UK weather. By the way, you can choose to do between stats. It's optional. Oh, is it? Is it optional to do between stats and mechanics? All right, you do that. But guys, rest of you guys, just make sure you do both. All right. All right. So, how is this looking so far? Is this all making sense? This was a pretty decent large data set question. The thing you needed to know for this is when where the locations are in the geography. Sometimes, okay, these are my things you need to know for large data set that are very, very important. Let me try and think of them. So you need to know where all the geographic locations are in the UK and in the world. So you've got Jacksonville, Shanghai, and Perth. The thing about Perth is very special. It's in Australia, which means it's in the southern hemisphere and the seasons are switched. So when we have our summer right now, they are having their winter. So you need to remember that in case it comes up. I, however, forgot that. So I'm saying this from experience. You need to know which areas are coastal and which are not coastal, like inland. So if an area is coastal, then it's likely to have a higher, greater mean wind speed or maximum gust. You need to know about where they are on the maps so you could do directions. I did that in my previous stats live. What else do you need to know? The variables. You need to know what all the different variables are. It's not too bad. Like, you just know it, know what they're measured in, their units, and know special things about them. So for example, special thing about the total rainfall is that between 0 to 0.05, you have a trace recording. And the value you use in the exam, this is very important. It's also in my TikTok. You take R at 0.0 was it 0.025 when working. It's the midpoint of that. That is a value you take R when doing calculations with trace. You need to do that. Things about humidity. Guys, tell me in the chat, what is humidities above 95% associated with? Enjoy. Do you need units for the mark? No, the mark scheme doesn't give it in units, but always give units, just in case. Just always give units. Your UK drawing is Africa? Mist or fog? Yes. Humidities above 95% are associated with mist or fog. And you have to know about the unit and oh no, I'm thinking of driving theory for that one. Ignore that last part. So yeah, mist or fog. What else can I say you need to know about DLDS? I think that okay, the months you need to know when it's from. So I remember it's May to October. So you need to know that, and you need to know the 2 years. So the 2 years are 2015, which is not too difficult to remember. That's just 10 years ago. And 1987. The way you can remember 1987 is just 987 backwards. All right, that's nice and simple to remember. And yeah, 87 and 15. Awesome. What else can I tell you about the large data set? Honestly, if your mind is blanking in the exam, just put an answer and kind of, if you have to sacrifice those marks, you do. Like, if you either know it or you don't, unfortunately. But yeah, what pure topics do you think they will mix in the applied paper? They could mix. I feel like they're gonna definitely have differentiation and integration in the mechanics because that is a topic itself. They could put that in stats. They did that in 2023 with an integration. Parametrics. They may put parametrics in mechanics. Who knows? Because you can model with parametrics to do weird stuff. So if they're evil and do that, because I don't think you guys had tough parametrics. So modeling with parametrics, but I don't think it's completely likely. Sequences, yep, they had an arithmetic series discrete distribution question before. So yeah, what else topics do I think? I had a few in my mind which I wanted to say on the live. If they come back to me, I'll let you know. But yeah, make sure you know that what would you integrate in stats. When you're doing stats actually has integration, but that's like further stats too, but that's really advanced. But they could get you to integrate the area under a normal curve or something to get one or something. I don't really, yeah, that whatever they give you, just do it. If they give you an integration type question, which is going to be slightly harder, they are not going to make it impossibly hard as if they're expecting you to do a pure paper. Just think about how Edexcel is writing these exams. They're not going to get you to do something completely irrelevant when they're trying to assess applied. That's how you do it. Let's see, any other questions? Find the head officer. Guys, I am a student. I'm in university. I'm not a teacher. So yeah, awesome. That's how you do a large data set question, and that's a bunch of the stuff you guys should know for that. So, question 4. Question 4 is a very nice question because it's just a standard textbook style question. So, a dentist knows they love dentists. They have dentists in a lot of these papers. Knows from past records that 10% of customers arrive late for their appointment. A new manager believes that there has been a change in the proportion who arrive late. You see this word change, you're going to straight away above put this thing. You're going to put the not equals to sign and you're going to put two tail straight away, just so you know. A random sample of 50, so you put n above that, of the dentist customers is taken. Write down null hypothesis for no change and alternative hypothesis. Wow, they even tell you what you have to write. So yeah, part A, very, very simple. The null hypothesis is that the probability is still going to be 0.1, right? 10%, there's no change. The alternative hypothesis is the probability is not 0.1. Why? Because it's a two-tailed test. That's how you do that. Part B, using a 5% level of significance, find the critical region for a two-tailed test. They even tell you that, so you can verify part A. Of the null hypothesis in A, you should state the probability of rejection in each tail, which should be less than 0.025. So the way you guys have to do this type of question is by using the probability tables in your formula book. So firstly, what do I say with these? Define the variable. The variable has not been defined yet. So x is your variable, because it is always that, is the number of late customers. I don't know why they're calling the patients customers in this. It's kind of weird. Then you have to assume that HO is true. So you can write your distribution. Therefore, x is going to be, so which type of distribution do we have here? Well, I've only got two outcomes, right? They're either late or they're on time, or like they're not late, right? So it's going to be binomial. It's not normal because you're not measuring anything continuously, and it's not equal because it's 10%. So x is binomially distributed, and it's going to be 50, and the probability you're late is 0.1, that's 10%. So I need to find the critical regions. So the way I laid this out, customers, because you pay. Oh yeah, customers, because you pay for the dentist. So the way I like to lay it out, and this is how I'd recommend, because it's neat and it just shows a bunch of working to the examiner. And I've been told by my teacher to do this. So I'm going to do the lower tail. So the lower tail is the probability that x is less than or equal to some value. That probability has got to be less than 0.025, right? Because that's the region over there. So I'm going to look at my table in the formula book and find the values below 0.025 and above that, and then like straddle against that value. So question 4 here, n is going to be 50, so I know that I'm coming to this one. What is my probability? It is going to be 0.1 because it's 10%. So now I'm going to look for 0.025, something below that, which is this one, and this one is above it. So it lies between there. So the probability that x is less than or equal to 0, which is just 0, is going to be 0.052. And the probability that x is less than or equal to 1 is going to be 0.0338. And I'm going to write both of these down in my thing. You can use a calculator as well. I like to just use the table because the values are right there and it's easier. So the probability that x equals 0 is equal to 0.0052, and x is less than or equal to 1 is equal to 0.0338. This is less than 0.025 and this is greater than 0.025. So we know that this is going to be my critical region. So lower tail, x is equal to 0. And it's said to state the probability, so I just say p equals 0.0052. So that's how you do the lower tail. Now we have to do the upper tail. So the probability that x is greater than or equal to x has to be less than 0.025. So what values am I going to look for here? Well, I'm doing the upper tail, so I could just do 1 minus 0.025 to get 0.975. So I'm looking for values below and above this to compare to. So if I go back to my table, because I like to use the table to help me out. So I'm looking for 0.975 on this in this column. So where is that? That is going to be, this is above 975 and this is below 975. So I'm going to take these. So the probability that x is less than or equal to 9 is 0.9755 and 8 is the one above it. So the way you write this out, so if you're doing 1, because we're doing 1 minus the probability there, right? So if you're doing 1 minus the probability that x is less than or equal to 9, what is that the same as? That's the probability that x is greater than or equal to 10. In an exam, I would literally write it out in the order I showed you. 1 minus that is that. That is going to be equal to, oh man, it all wrote that. So I'm going to show you my plan over here. So that is 1 minus the probability from your table, and you get 0.0245. Now you have px is greater than or equal to 9 is 1 minus the probability is less than or equal to 8. That is 1 minus that value, and you get 0.0579, which is greater. We want it to be less than, so we take this one as our critical region. So that's the probability x is greater than or equal to 10. So the upper tail, we say x is greater than or equal to 10, and state your probability again, that. 0.0245. So therefore, you could just say your critical region, I'm going to put that at the end for part B. I'm so upset it's all gone. So the critical region is x is equal to 0 or x is greater than or equal to 10. You could literally put the word or there as well, or a comma. So yeah, that is how you find the critical region. And part A is just P equals 0.1 and H1. P is not equal to 0.1. So yeah, that is how you do a critical regions test. And this method that I did here gets you full marks guaranteed, because you're also, well, if you do the correct numbers, obviously. This method, you're showing that you're checking above and below the the value. So you're confirming that, yes, that is the one you're doing. So yeah, that's how you do a critical regions question. Part C, find the actual significance level. So for that, you just have to add the probabilities of each. So the probability of x, which we found, was 0.0052 plus 0.0245, and you get 0.0297. Easy 1 mark. Just add the probabilities that they fall into the critical region. So the actual significance level, just for definition, is you add the probability of the critical regions, which is where results are significant. Yeah. So in this area and this area, you're going to have significant results. So the significance level actually is the probability of that plus the probability of that. That is how you do it. Right. Do you have to do set notation at the end of your answer? You don't unless it requires it. So if you wanted to do set notation, there. But you don't need to for this one, okay? The reason is because the question didn't say, but know how to do set notation. The way you do set notation is you've got your variable x, and then you're gonna say x is such that, and then like let's say x is greater than 5, and then you put your set notation brackets around it. That's how you do it. X is such that x is greater than 5. That is a set notation example. That has nothing to do with this question, but that's how you write it, because you got that in paper 1 and paper 2. So it's good I went through that on my life before paper 2, but I'm going through it again here. This is how you write out a set notation, all right? You can also have, if it's like greater than 5, but it's also less than another value, and there's a gap between, you can do 2 sets of boxes. That's cool too, all right? Part D. The manager observes that 15 out of 50 customers arrived late. With reference to B, comment on the manager's belief. So B was my little test, right? So I have to compare. Remember, whenever you have these values, put an inequality sign in. So 15, I'm comparing that to my upper critical region, which is 10. 15 is greater than 10. Therefore, you have to say 15 lies in the critical region. Write the full words, guys. Therefore, how are we going to phrase this? We say there's enough evidence to reject HO and support the manager's belief. And state what the belief is, yeah? That, I'm just going to show you the answer here. State the manager's belief that there's been a change in the proportion of late customers. State the entire thing there just in case they don't give you the mark for that. So yeah, that is what you do for this question. It's a pretty standard textbook type question, but yeah, I hope we get a good inverse normal question. Yeah, that'd be nice. So yeah, does this question make sense? I hope it does. Let me just check the chat. Awesome. So yeah, make sure you know how to do your critical regions for a binomial distribution and for normal. For that one, normal distribution, that is much longer. You have to use the standard normal and do simultaneous equations. But yeah, that is how you do this one. What about when the question asks, what is the actual significance level? Yep, that was down here. So day one, part C, the actual significance level. I said that. I'm going to show you my thing over here. Hold on, my solutions. So my solutions, just so you can see, the actual significance level is the probability of each critical region. So you add the probability that x is less than 0, which is that, to the probability that x is greater than 10, which is that. So when you add them, you get this value. And this value should be somewhat close to 0.05, which is your initial significance level. This is 0.03, so yeah, you could say it works. So the actual level is the probability that you'll have a significant answer. An answer is significant if it falls into the critical region. So all you have to do is add the probability of each critical region, and boom, there's your answer. Hopefully that explanation makes sense for critical regions. So we are going to do the next question. This question, I'm not gonna lie, is kind of fun. I'm saying that like thinking it is maths. Hopefully you guys enjoy maths. But yeah, initially I was like, this looks so long, but this is actually not such a bad question. A company has 1,825 employees. They are classified as professional, skilled, or elementary. And the following table shows the number in each classification and 2 areas where they live, A and B. An employee is chosen at random. Find the probability that the employee is skilled. So for part A, what am I going to be looking at? Probability skilled. So I just need to find how many employees are skilled right there. So that's just simply 275 plus 90 divided by how many employees there are. They told me there's 1,825. If they didn't tell me that, I would add up all these values to get my denominator, and you get 0.2. So that's part A done. Is the rest of your live? Yep, I'm gonna post my live as soon as I can. Straight away, I'm gonna be exporting it and uploading it onto my YouTube. So don't worry, it's gonna be there. Hopefully as soon. Yesterday's live uploaded so fast. I was so proud. So that is gonna be up as soon as possible. I'm gonna update on my TikTok page when it's up. So yeah, check it out there too. So part B. the probability they live in area B and they are not a professional. So I'm looking at this column, B and is not a professional, so it would be this one and this one here. So that's just probability B and not professional is equal to 90 plus 80 divided by my total, which is 1825, and we get 34 over 365 when simplifying. So yeah, nice little probability question to start us off with. Now, part C is where it gets long, but it's kind of fun to logic your way through if you like maths, which you guys hopefully should. So, some classifications of employees are more likely to work from home. 65% of professional employees in both area A and B work from home. 40% of skilled employees from both areas work from home, and 5% of elementary employees from both areas work from home. Event F is professional, H is home, and R is that they're from A. I don't know why they decided to put these random letters. F probably from professional and they can't put a P for probability, and A because that's just going to be confusing with that. So they put the second letter and H is home. That makes sense. All right. So the first thing I did was using this information, complete the Venn diagram on the opposite page. They have these letters here. I'm just going to write what each letter represents. So H is for home, R is for the area A, and F is for if they're a professional. Write it out so it makes it easier for you. Okay. So the way you have to do this is see each section of the Venn diagram that you want to fill in and find the probability in that. So part C, I need to be on pen mode. Part C, I'm going to do a bunch of different colors to make it easy. So this is going to be a very colorful sheet. So number one, I'm going to start up here. You can start anywhere you like, but I'm going to start here just because that's the only isolated one. And I'm going to basically, in words, say, what does this section represent? So this is an edge. So this is home, and you're not in area A, and you're not a professional. So home and not a professional and not area A, because that is just home on its own. So I'm going to look at area B on my table, and I'm going to find the two sections that are not professional. So I'm looking at B, and I want them to be skilled or elementary. And are they working from home? Yes. So I'm going to use this data here to figure that out. So how many are skilled? There were 90 skilled. And how many were elementary? There were 80 elementary. Now, how many of the skilled workers work from home? They're telling us 40%. So the number in home is just 0.4 times by 90. And I'm adding this as well because it goes into the same one. 5% of elementaries work from home, so that's 0.05 times by 80, and you get 40. So this value here is 40. Does that make sense, guys, so far? Let me know if it doesn't, and also let me know if it does, just so I know I have some verification there. All right. So for part 2, I'm going to pick another section. Again, you can pick any section you want. I'm going to do this section down here just to complete the center. Sorry if I'm going too quick. I will repeat part 1 one more time. So I need to fill out this Venn diagram. So the way you fill out a Venn diagram is you just see what section you have. 1 second. They're telling me to verify that I'm still doing the live by proving I'm not a robot. All right, cool. So I need to look at the section of my Venn diagram and see what it represents. So this section, I've picked this one over here. So this is just H. There's no area A and there's no professionalism here. So you're just having the probability that they work from home, they're not a professional, and they're not in area A. So I wrote that down here. That is what that area represents. So I'm going to look, if it's not area A, it's going to be area B. So I'm going to look at area B over here, and if they are not professional, they're either going to be skilled or they're going to be elementary. Good night, GW. All right, they're going to be skilled or elementary. So if they're skilled or elementary, I need them to also work from home. That's my third condition. Home is 0.4 times 90. Why? Because they're telling me 40% of skilled employees in both area A and B work from home. So 0.4, 40% of area B that are skilled is 0.4 times 90 plus 0.05 times 80. Why? Because 5% in this one work from home. That is going to be equal to 40. That's how you do this first section. I'm going to use that exact same logic to work on the other sections. So for this one, I need to think, what does that area represent? This is everyone who works from home and works in area A or lives in area A and is a professional. So I'm going to write that out for my reference, home and from a professional and from area A. So I need to look at area A over here, and they're professionals, so is that value there. I can ignore skilled and elementary in area A. I need them to work from home. Well, my thing here says 65% of professional employees in area A work from home. So I just have to do the same thing here. So home, you have 65%, which is 0.65, multiplied by, well, in area A, you have professional, I'll just make a note. That is 740 over here. And if you multiply them, you get 481. So this value here is 481. Just check the comments. Oh, it seems interesting. I'm glad it seems interesting. Yeah, do your best. Make sure you've got one more day. Keep pushing, all right? Then have the best sleep since for a while. You don't get it? All right, I'm going to explain again for number 2, and I'm using the same logic for each of these sections, all right? So I need to find the section here in this middle I've chosen, okay? What in my Venn diagram does that, oh, you've got, sorry, 2 more days. Yeah, for the chem log. All right, end of this week, then you sleep. All right, for this Venn diagram, this section here represents you being in H, you being in R, and you being in F. So I wrote that. You work from home as well, and you're a professional, and you live in area A. So I need to find the number of people who fit all this criteria. So I'm going to look at area A first, and the professionals in area A. So, oh shoot, it's still in pen. Give me a sec. Oh. All right, so if I go up here and I find area A, this is the number of professionals who live in area A, 740. Now, what's my third condition? It's H, home. So how many of these 740 work from home? They're telling me here 65% in both area A and B, so that you can do them separately, work from home. So if I've got 740, 65% of that work from home. So I'm doing 65%, 0.65, times by 740 equals 481. That was a big Venn diagram question last year. Yeah, the Venn diagram question I think was the last question last year. Why am I saying I think? I know it was. I did it. So you never know though. You actually never know. But if I had to predict, I predict you have a box plot or a histogram or a cumulative frequency one if they're not a Venn diagram. Anyway, hopefully that explanation makes sense for number 2. I'm going to follow the same logic but changing colors. Remember, today is going to be rainbow. I'm going to do the same logic on number 3. So number 3. I'm going to pick this as my third area. So now, what does this area represent? You're in area A and you're a professional, but you're not working from home. So you're a professional and you're in area A, but you're not working from home. So I'm going to look at area A and find the professionals. Professionals in area A is 740. We know that from up here as well, right? And if they're not working from home, well, we know 65% work from home, so 35% don't work from home. That's equal to 259, and that's what you put there. The last one, I'm going to pick color from the wheel. I'm going to go light blue. Number 4 is this section. Do not forget that the section outside the circles also exists. So this section is not F and not R and not H. So if it's not R, it's going to be area B. And if it's not a professional, you're looking at the skilled and the elementary workers. And it's those who are not working from home. Well, I know that there are 90 skilled workers from part A, and there are 80 elementary workers. If 40% work from home, 60% don't work from home if they're skilled. And if 5% work from home there, 95% don't work from home if they're elementary. And that is equal to 130. So that is my Venn diagram filled, and this is how you do part C of the question. Let me just check. Is this making sense, guys? Suns never look brighter. Suns never look brighter, but it's so hot. Waffling might be key. Yeah, just write down. Stats is a bunch of waffle, alright? So, that's part C, Venn diagram question. I'm going to put this over here as like a summary. This was my notes. Take a screenshot of this if it helps you logic it through. It's got all the writing as well. So see what each section represents, then write it out. So there I've written what that blue section represents. Then you have area B, which is not area A. And if they're not a professional, they're skilled and they're elementary. If they're working from home, they've told me the probabilities in this part of the question, 40 and 5%. So I find 40% of that and 5%, add them, I find that. I use the same logic for the rest of this question. All right, so you can see that. That is the answer for this, and it's very colorful. Ignore the highlights for this section. That's for the next bit. Awesome. We are going to move on to part D, E, and F. It's a long question. So for part D, find the probability that not R, find the probability of not R and F. So going down to part D. I'm going to do it down here just so I can redraw this Venn diagram. So the probability of not R and F, and if I fill this in, I have a 40 up here, 481, 259, and 130. So yeah, I've just filled it in from my thing. So what's the probability of not being from area A and being from F? So this, I'm going to use highlighter to show you the areas. And I'm going to use some nice colors. I'll use yellow because why not? So yellow represents this. So if I'm in F, I'm looking at this big circle here, but I am not in R. These values include R, so I don't include those. So this is what my area looks like. So now I just need to find the probability. So I just add 247. That's meant to be a 7 plus 133 divided by the total number of employees, which is the same entirely in the question. And you get this as your answer. And you can leave it as a fraction. You can put decimal as well. They accept that, but I like to leave it as a fraction, nice and clean. You can do it, this question. Now, my advice is, if you have not filled out this, oh, they put a line through there. If you have not filled out this Venn diagram, you may refuse to do them. Don't. What you have to do in your exam, and I'm telling you this is so important. Part D, you actually don't need to have anything filled in because you can see these values were already given. So you can do this without doing part C. Now, for part E and F, you need to have the values filled in. But what if you don't know how to do that or you're struggling with that? Make up values for them. Values you make up, at least make sure they're more than 0 in all of them and use those numbers because they will give you marks. Sometimes they'll give you marks if you use the correct method, right? So I'm going to show you what the mark scheme says for E and F later. Just know, if you don't know how to do a part previous and the next part requires it, make up a suitable number that looks like it makes sense. That is super, super duper important. All right, part E. The question is this. This is the question in part E. The probability of, one second. The probability of H, why is it a rubber? H or R, but it's the complement of the entire thing. That's what the question says. So I'm going to look at my H or R section and just work my way from there. So I'm going to pick a nice light purple. There we go. So now what is the probability of H or R? So your H is going to be this section, or it could be R. So it's going to be this entire like goggle shape there. But the question tells me I want the complement of that. So I don't want anything in this big purple circle. So I'm seeing the correct answer in chat. Almost, not 233. You have to add this 263,007. So this is going to be this value plus this value. These are the only ones lying outside that intersection circle, that union circle. So that's going to be 133 plus 130 divided by 1825, which is just 263 over 1825. So now I just need to remind you, make up numbers because they give you the mark as long as 130 is greater than 0 here. So 130 is the number you don't have initially. If you don't know what it is, put a suitable value. Put 100 there if you want. Then do your working because they may give you the mark for following through the correct method, okay? Do that. Please do that. Don't waste your marks and don't feel put off. So part F, the probability of F given H. This is what the question says, all right? I can just write out the formula I know. That's the probability of F and H divided by the probability of H. So what is the probability of F and H? Well, F and H, I look at my F circle and I look at my H circle. This is their intersection here. So that's just 247 plus 481. I just want to mention a point here that this is technically, this bit up here is not a probability because it's just an integer. The reason I'm not writing the denominators is because one, I'm being lazy. They're going to cancel when I'm dividing through here, right? Because the 1825 divided by 1825, that's going to cancel out. That's why I'm not writing it out here. Now, divided by the probability of H. Why? Because it's given H. So that's just 40 plus 123 plus 481 plus 247. I've added all the values in my H circle up there. If I put that into my calculator, you get 728 divided by 891. And that is your answer for part F. Again, make up numbers. How does this look so far? Finding probabilities from Venn diagrams, pretty nice. They had it last year. It could come up again this year, could be one of the earlier questions, but it's unlikely to be one of the harder questions. However, you never know. It's good to always know. So that is how you do this question 5 Venn diagram question. Quite a long question. That's the end of that. Now we've got one last question in this stats paper before we move on to some fun stuff, mechanics. So this question is actually a pretty nice ending to this paper because it's not too bad in my opinion. This is about linear regression and linearizing with logs and all that. Anna is investigating the relationship between exercise and resting heart rate. She takes a random sample of 19 people, N, in her year at school and records for each person their resting heart rate, H, beats per minute, and the number of minutes, M, spent exercising each week. Her results are shown on the scatter diagram. So this is my scatter diagram. We've got as M increases, you can see H is decreasing. All right, cool. Interpret the nature of the relationship between H and N. I need to tell you, this interpret word means you need to provide context. Context is so important. You cannot just say there is a negative correlation. You need to say, like, provide some context to what is there a negative correlation between or what is happening. So in this type of question, I like to say both, just so I know I've hit the mark some way or another. So here, I'm going to interpret the nature. As the number of minutes of exercise increases, the resting heart rate decreases. And that's what I'm going to write. As the number of minutes of exercise, write the full word in your exam, guys, by the way, which is M, increases, the resting heart rate, which is H, decreases. There is a negative correlation between M, which is the number of minutes of exercise, and H, the heart rate. That's what you'd say. You need to interpret, you need to give context for this question. So I'm going to just show you what I put in my notes for this question over here. As the resting heart rate is down here, as the number of minutes of exercise increases, the resting heart rate decreases, or you could say the gradient of the curve becomes flatter as M increases. What does that show? It shows that any extra minute of exercise does not have as significant effect. It has a smaller effect on the heart rate. You allow you to say there is a negative correlation between between the number of minutes of exercise and the resting heart rate. You have to say those full words, however. I'll just show you the mark scheme, like I said I would. And for that's not the mark scheme, hold on. There's the mark scheme. So this one, look, it also says allow them to follow through with their answers in the Venn diagram question. For this one, there we go. You can see the answers down there. And if you scroll down to A, it says in B1, allow there is a negative correlation or association relationship exponential between minutes exercise and resting heart rate, but they've underlined the words. So you need to say the words fully to give context, all right? Let's go down. So that's part A. Let me just check any questions. What do they add differential equations with exponential? Knowing at Excel, they could. So just know how to do differential equations. I've got a video on it, I think, doing rates of change with differential equations. They'll have the same concept about splitting the variables and plugging in values. Do you have to say about the gradient flattening? That is one of the things they allow you to say. Let me just show you the thing here. So you don't have to, but you can. It's a good thing to point out. Gradient of the curve becomes flatter as m increases. What does B1 and NB mean on the mark scheme? Do deviate on a quartic. This is not science. What does B1 and NB mean in the mark scheme? B1 is a type of mark you get, like they have a thing up here. You can see B marks are unconditional accuracy marks. And let me scroll up. And NB, oh, what does NB mean? I forgot what NB means. You can see this is the thing. Quartic distribution will come up. Damn, what is a quartic distribution? Never heard of that. It's crazy. So I'm gonna go down and move on to the next part. We're gonna quickly wrap this up as fast as we can because I want to do some mechanics. So Anna codes using the formula x equals log 10 of m and y equals log 10 of h. Awesome. The PMCC between x and y is that. So that's my R value, right? Test whether or not, so I'm thinking two-tailed initially, there's a significant evidence of a negative, okay, this is telling me it's one-tailed, negative correlation between x and y. So you need to see what type of correlation are you proving. And x and y are the coded values, so they're going to have some sort of linear thing because you've linearized it, right? So here, she is trying to linearize. Boom. So this is just a hypothesis test for PMCC. So my null hypothesis is that rho is going to be equal to 0. This is telling me that the PMCC for the whole population does not show any correlation. So that is my null hypothesis. And make sure you write your letter rho like a rho. Don't write it like a P. Don't join that bit and make it more slanted, just so it's clear that that is your letter. The alternative hypothesis is that rho is less than 0, right? Because if it's less than 0, it's going to have a negative correlation. That's what we want to prove. So my sample size, this is how I laid out my questions to make it neat and understandable. Sample size is n equals 19. It tells us in the top of the question, she takes a sample of 19 people at her school. So I need to say the rho not p bit. I need to say it. So the sample size is n equals 19. So at n equals 19, at a 5% significance level, I need to find my critical values, right? So I'm going to show you how to do that by using the table. So critical values, n equals 19, and 5% significance level. Why am I scrolling like that? Just scroll down here towards the end. There we go. So you want to look for this. So n equals 19 is going to be in this line. And what is my significance level? 0.05. So if I follow along, I get this value here, plus or minus 0.3887. So that is going to be equal to plus or minus 0.3887. These are critical values. However, since we're testing for a negative correlation, the critical value equals negative 0.3887, right? Because it's a negative correlation. That's like that. So that implies that the critical region is less than negative 0.3887. So R, what is the R value that they calculated here? Negative 0.98897. So 0.897. And you're comparing it to the critical value. It is quite obviously less than it. So it is in the critical region. Therefore, you just have to finish your conclusion. Enough evidence to reject the null hypothesis, HO, since the PMCC, the product moment correlation coefficient for the whole population, is less than 0, is negative. Therefore, enough evidence, and you need to put both of these lines, to suggest a negative correlation between H and M. So yeah, that's how you do a PMCC hypothesis test. I'm going to say the row bit one more time. Make sure your rows look like rows and not like peas. But yeah, let's go up. Any questions? Right is slanted, don't join the curve. Yep, I don't know if I trust predictions after that last horror. Yeah, don't trust predictions, but have a guess what is going to come up. Alright? Have a rough prediction of what you think is going to appear in the exam, just so you know and you're not shocked. Okay? Will you get marked down for P? My teacher said to be very, very careful that examiners don't see a P. They said that you could get marked down, which is why I've always been very careful with it. So let's see what the mark scheme says. Oh, they actually allow you to say P here. Okay, they're being nice here. My teachers have always told me be very cautious. Okay, cool. So they allow you to say P. I'm guessing a lot of people did that, but make sure it's obvious that you're not talking about P because P could mean probability. That's what P stands for most of the time, right? With the binomial distribution. But write a row. Don't write a P. All right. I don't want my solutions. I want my question paper. So yeah, that's how you do hypothesis test. One last part to this question, and then we're done with stats in this live. The equation of the line of best fit of y on x is this. Use the equation of the line to find a model for h on m in the form this. So we know in the textbook it tells us how to go from this exponential form to a linear form. We're basically going the other way. And I'm going to show you how to do it. It is just by substitution. So the equations, I'm just going to copy them again down here. Y is equal to minus 0.05x plus 1.92. What do I want that to look like? H equals am to the power of k, okay? That's what I want to look like. So, how am I going to do this? Well, I know y and x in terms of h and m. They told me in the question, y is coded, that is log 10 of h, and x is log 10 of m. Just replace it. Log 10 of h equals minus 0.05 log 10 m plus 1.92. Now, how am I going to go from this to this? Well, I could use log laws and try and find an exponential. So if I add this bit onto both sides and I just raise it to the power of 0.05, I get log 10 of h plus log 10 of m to the power of 0.05 is equal to 1.92. Now I know my log laws. If the log has the same base, which is 10 here, and I'm adding the logs, you can multiply the things inside them. So it's log 10 of hm to 0.05, which is equal to 1.92. This is telling me 10 to what power is hm to the 0.05? Well, 10 to the power of 1.92. So hm to the 0.05 is equal to 10 to the power of 1.92. Now, I want to get h on its own, so I'm just going to divide through by m to the 0.05 on both sides. So I get h is equal to 10, 1.92, let me write 92, divided by m to the 0.05. I have not yet done the question because I want m to be above. So all I've got to do is raise m to a negative power to get it up there. So h is equal to 10 to the 1.92 m to the negative 0.05, because we know negative powers make it a reciprocal number. So this is my final answer. So what are the letters? So I could then just put a here is 10 to the 1.92 and k is equal to negative 0.05, and that is it. They also allow you to say that it is 8.83.2 to three significant figures, and write it like h equals 83.17, so on, or rounded m to the minus 0.05. I've left it as an exact value here, or as a value to the power here, because they haven't told me they wanted any of these to three sig figs or to what level of accuracy. So this is how you would do this last question there. How does this question look, guys? That is a wrap on my stats lives for 2025. Don't go anywhere. We're going to do mechanics now next, which is going to be more fun. I love mechanics. And the mechanics paper we're going to do is a pretty decent one. So, does this question make sense? We have just done substitution. Yep, Brent, one paper done, one to go. In the middle bit, I need to continue stats. Best of luck with stats. I've got my previous lives on my YouTube if you want to check them out there as well. Thank you for all the gifts and roses, Bryn, and everyone else. Really appreciate that. But yeah, I said that I would be doing like my top tips, right? Did you guys want to hear advice for stats, or do you want to just get into mechanics, or what do you guys? Do you want me to give you some advice for the exam stats and ask any questions now? Top tips, yes. All right, cool. So I'm just gonna make a note on this for anyone who joins. Starting mech soon. Giving tips now. Okie dokie. So my tips for statistics, I'm gonna look at my textbook and refer to some things as well. So know the topics in the textbooks. All right. So for year one stats, you've got data collection. What are my tips from that? Know what the different methods are, and there's two types. There's random and non-random sampling methods. I know their pros and cons. I don't think that's come up for a while, so I have a gut feeling they might have a question about sampling techniques or something to do with sampling in your paper. It's going to be 1 or 2 marks, but every mark makes a difference. The large data set, I already gave my advice on that, and if you want to check out that advice, it's going to be on my YouTube channel later. Measures of location and spread. Make sure you know about the discrete and continuous difference when you're doing the different quartiles or rounding, right? So if you've got a like a table and it's been given values and it looks something like, let me just draw it out here. So your table looks like it's giving values from 1 to 2 and is like that. You need to take your range to be from 0.5 to 2.5 as a continuous, right? Because it's exactly the same. It is a continuity correction, like in approximating a binomial. So make sure you know the nuances in each of the chapters. Just reading through the textbook will already help you. Quota is picking who fits your exactly opportunities. Just walk by. Yep. Let me show you the book, actually, that section, so you can see the words. Where is the sampling? There we go. In quota sampling. Here we go. I'm going to just show the book right now. Here is what it says. In quota sampling, an interviewer or researcher selects a sample that reflects the characteristics, so they're doing it proportionally, but opportunity is like you're jumping at that opportunity. All right? So that is a definition in the textbook. That's where it is. What else should I say for stats? Make sure you understand how to do Venn diagrams, because some of the Venn diagram questions can be a bit weird in terms of what goes where. So make sure you can logic, like we did with that triple Venn diagram, logic your way through each section. Make sure you're happy with histograms. So I have a feeling histograms, box plots, or cumulative frequency might come up in this paper. I have a gut feeling for that. So make sure you're very happy with those, and scaling. And those are like my general advice for things like small things you need to remember, which you may have forgotten. Now, tips for the exam. If you do not know the answer to a previous part of the question and the next part of the question continues on from that, make up values, but make it clear that what values you're making up. All right, just so you can get those method marks. And sometimes they will allow you to get the wrong answer, but with the correct method of working, as long as you've made a proper attempt and use an appropriate guess. So for that Venn diagram question, if you didn't know what some of those values in the Venn diagram were, but you had a guess, for example, this one over here, and you had your working, they would have given you the mark in this type of question. But yeah, never leave anything blank. Just put an answer down. Probabilities add to 1. If you don't know how to start, move on. Exactly. Come back to the end. So when I was doing my statistics exam last year, question 1 actually stumped me in my stats. And that was the first question I decided to do. I did stats and mechanics. So question 1 stumped me. I didn't waste time. I was like, no, I've got so many more questions to do. Move on to question 2. Finish your stats. I went back to question 1. Still didn't have an idea what to do. So I did all my mechanics and had time at the end. So I went back there and I was like, okay, now I've got time. I can logic it through, and I managed to do it in the end. So make sure you go with that. Do you recommend starting with stats or mechanics? Personal choice. I did it, so I chose stats then mechanics because I don't like stats, and I wanted to end on a more fun thing. So I did the thing which would take me longer, which was stats. Because mechanics, I felt I would be fine doing mechanics with time pressure. That's my reasoning. Do what is most comfortable for you. I recommend after this live or tomorrow morning, do a stats and mechanics paper and pick an order to do it. See how that order works. If it works, do it in your final. If it doesn't, switch the order. Yep, I took my A levels only last year, so it's still fresh in my mind, and I know exactly what like most of us struggle with or like find difficult and the tips, which is why I'm just giving you all my advice from that. So yeah, any other tips? Probabilities add to 1. Make sure that's an important fact when doing probability distributions. Yeah, those are my main tips for stats. Let me just check the year 2 textbook if there's anything important. Oh yeah, know the normal distribution. Know that, yeah, because you'll have it in your mind. Know the normal distribution so well, because that is going to be a big question. Like it's always a big question every year. So if you're fully happy with the normal distribution, you'll be good to go. So if I walk through the thing, of the textbook, the first part just tells you about the normal distribution. Second part is finding probabilities, and the third part is finding the inverse. Those are all pretty decent stuff. That's all calculator like things we should be good with. Then you go on to the standard normal distribution, which is just replacing the x with z's and using that distribution. Finding mu and sigma, you have to use the standard normal distribution to find that because you don't know, you can't use the inverse normal because you don't know what mu and sigma are. Approximating a binomial distribution, know the formulas for mu and sigma there. So mu is np, sigma is square root of np 1 minus p, and know why you can do that if n is large and if p is close to 0.5, because then it'll give the bell-shaped curve. And hypothesis testing, the last video I posted goes through that. Know about conditional probability formulas, so you know you're given that formula, you need to know those. And about tree diagrams is for successive events. If you've got one event happening after another, that's when you use tree diagrams. They may not explicitly tell you to do a tree diagram, that's why. And know how to use log laws. Log laws and exponentials is guaranteed to come up, I'm telling you, because of linearizing the thing. I mean, regression, right? What are other high yield topics? So those are the main stats ones. I'll go to the mechanics ones afterwards. So for stats, high yield topics are probabilities for sure and distributions, the normal distribution, and then from year one stuff. Data collection is not really high yield, and the large data set, they're more small, but they're almost guaranteed to come up. Measures of location and spread. So your averages and your spreads are guaranteed to come up in some form. Representations of data, you're going to have one question or two on that. So that's on outliers, box plots, cumulative frequency, and histograms, and comparing data. When comparing data, you compare their mean averages or median averages and see which one is higher, or you compare their interquartile ranges or their ranges and say which is more spread out. That's what you have to do for that. That's it. And yeah, probability, hypothesis testing, very high yield. Make sure you know how to do 3 types of hypothesis tests. You need to do it for binomial, for normal, and for PMCC, and make sure you're happy with the critical regions for binomial and normal. And yeah, those are the high yield topics. Is the 2022 paper hard? This is the 2022 paper we just did. I found it not too hard. That's just my opinion. But yeah, that was Is most of this covered in the stats vid? Yep. Most of the stuff I've said has been covered in the stats live where we did 2 papers, so there's a higher chance of that. And if there's not covered, obviously check your textbook, Google other videos and stuff, so it's all there. How do we go from Poisson distribution to normal distribution? So Poisson to normal. I don't know. I don't think we need to do that, and I think the further stats exam is already done. So unless there's further stats 2, I have not learned Poisson to normal unless that's covered in further stats 2. I've done further stats 1 and further mechanics 1 and further maths. Could you explain October 2020 question 4 stats? I've done that on my stats live. So go to my YouTube channel and it should be in that video. So go to that and the explanation is over there. Damien. Oh, what are you doing with Poisson? Yeah, Poisson is further stat stuff. I saw that the Axis students had an easier preference. So, yep, on my video on YouTube, they're going to be different grade boundaries. I'm not doing maths, I'm doing computer science. Who do you recommend to watch if you can't understand the stats topic? The people I watched when I was doing my revision, Bison Maths is a lifesaver. He has those mind map vids in the morning of the exam or right before while I was eating my breakfast. I just watched that to get an overview. Zishan is also quite useful for maths, so check him out too. I've got some videos. Obviously, I've just started a while back, so I'm going to be uploading a bunch more over the course of the next few years. That's going to be like my little side project. So I'm going to have a bunch more too. But yeah. What year is the stats question with the integration? That's 2023. I believe I have not done that yet, but there's some videos out there for that. But yeah, okay, cool. I'm going to jump right in and we're going to do some mechanics stuff, which is the June 2022. So this, guys, is going to be the final paper for this exam season that I'm going to be going through. I'm getting kind of sad because I've enjoyed doing these lives, I'll be completely honest. Also, what year is that hidden hinges mechanics question? Did that come up? I don't remember. I don't know if there's been a hidden. There may have been. I may have just not seen it. But I posted a video on hinges. Hinges are not too bad. Literally, at a hinge, you've got a reaction happening at a hinge, right? And it's happening at an angle. you don't know what that angle is, so just assume a horizontal and a vertical component and continue resolving and doing moments as usual. Check out the sign video I did. Are hinges in the spec? It is in the spec, and it's not, it is in the textbook actually. I found it. If you have your textbook now, I'm going to tell you where to go. The textbook, it is in section 7.4, I think. Yes, section 7.4, page 144 is example 9. That is the example on hinges. I'm going to show you if you guys want to take a screenshot of this. This is the example on hinges. That is where it appears in textbook. They have not made as big of a deal about hinges as, they should have. But yeah, I've also got a video on that posted. This is my second last video posted. All right, cool. Mechanics. Just let me know, guys, in the live, what are your thoughts on mechanics? Do you like mechanics? Do you not? Yesterday, people love mechanics. I think generally people love mechanics, but what are your thoughts, those of us who are in the live? It is the best part of maths. Like, you can see my little happy face there, even though it is the final paper. But yeah, I've enjoyed doing these lives. I'm going to continue doing this on in other exam periods. Maybe if there are resits, I might do geography or GCSE there. But yeah. So, back on mod work for mechanics, exactly, honorary. So, we're going to do some mechanics. Can you wait a couple minutes? Yep, I will wait 2 minutes. Paper 32. Yeah, it's weird. I don't know why they didn't put a decimal dot. So yeah, I'm going to starting, if I can write with a pen, starting at 19, let's go 1940. It gives us a couple of minutes. Stick around for 4 minutes if you're good. In the meantime, can keep asking me any questions if you have any. In this paper, let me tell you what topics we are going to do in this. Mechanics, my solution. Questions if you have any. In this paper, let me tell you what topics we are going to do in this. Mechanics, my solutions. Is the same name, at I'm a user. And it's the same profile picture. If you type in a user on YouTube, it should come up with my little character, which is me as a character. I'm just gonna put my phone on charge. I really need to charge. Okay, obnoxious angle. How am I gonna? There, and if I put you. Okay, how is this view? I'm trying not to put it at a weird angle, but it's only falling. It's falling. Sorry, guys. Okay, so this is gonna be. Alright, don't move my phone. Awesome. Boom. There we go. Nice. Have you seen AQA paper? I have not seen AQA papers. It's pretty steady. Would economics, maths, psychology, or law be a good combination? Yeah, that seems like a pretty decent combination. You got maths, you got humanity, economics. Yeah. It depends on what you want to go to, obviously, right? If you want to go into being a lawyer, that is a perfect combination. Well, not perfect. Like, that is a very, very, very good combination. I don't know what the perfect one is. But yeah, just match your subjects to what you want to study at uni or potentially what you want to study. For me, I didn't know what I wanted to study, but I knew I wanted to do something maths or sciencey related. So I just picked those subjects from my A levels. Awesome, very nice. Scroll up. I don't know which one is better between psychology or law. Yeah, laws don't want you to study law 99% of the time. Study psychology from psychology or law. That's what my friends have also told me. One of my friends is studying law at uni. She didn't do law at A level. She's all good. Motivation is solo right now. All right, I'm gonna try, and my aim by the end of this live is to motivate everyone in my life. So we're gonna do mechanics. Mechanics is fun, so that's gonna be motivational. And stats is we just did, so it's all good. What topics do you think will come up? I'm so scared for mechanics. I'm gonna try and make you not scared for mechanics. So mechanics, things that I know for sure may definitely come up. You're gonna have some variable acceleration stuff. You're gonna have a weird forces, applied forces question. You're gonna have something on a slope. Something is going to be on the slope. So make sure you know how to resolve up and down a slope by heart. Question 2 is going to be that only, exactly. You're going to have vectors. You're going to have differentiate and integrate in that paper. You're going to take moments. You're going to do projectiles. This is the stuff that's going to come up. Stat mechanics, very, very predictable. Paper 3 motivates me to end it all. Well, paper 3 is the end of, hopefully, most of people's alls exams. So, yeah. I swear. Awesome, guys. And if you know anyone else who's struggling with their revision, feel free to share the live with everyone. And I appreciate all of you guys' support and for sticking around. It's made my day, made my week. But yeah, awesome. We are going to start in a minute, it seems. So, mechanics. Mechanics is more predictable. Make sure if you want good mechanics practice and you've gone through the textbooks and know how to do the stuff, bang out all the past papers you can, because the chances are your final paper is going to look quite similar to the past papers. Okie dokie. It is 7:40. Let's begin. Let's change color from red because that looks kind of satanic to black. So final paper, guys, of 2025 for me, from my side. Question 1. So, at time t seconds, where t is greater than 0, a particle p has the velocity v meters per second, where you've got this. This has t's in it, right, in the equation? So this is non-constant. So it's a variable acceleration question. Therefore, what do we have to use? We have to use calculus, guys. We cannot use the SUVAT formulas for that. That's all gone away. So I'm just going to put calculus, variable acceleration. So find the speed of p at time t equals 2. Well, they've given me the velocity. What do I know about speed? That is the scalar, or the magnitude of velocity. So let's find the velocity at t equals 2. So that's v is equal to 3 multiplied by 2 squared I minus 6 times 2 to the power of a half j. In my calculator, that gives me 12I minus 6 root 2j. You don't need a calculator for that, though. So your speed is going to be the magnitude of the velocity. So you're just doing some Pythagoras. So square root of 12 squared plus 6 root 2 whole squared. And that gives you an answer of 6 root 6 meters per second. Or if you wanted, 14.7 meters per second to 3 sig figs. Part A done. Nice, 2 marks over there. Part B, find an expression in terms of I and j and t for the acceleration a of p at time t seconds where t is greater than 0. Basically, find an equation for acceleration. So what does acceleration mean? That is the rate of change of velocity. So that is dv by dt. So all I've got to do is differentiate velocity. So if I differentiate, I get 6ti minus 3t to the power of minus a half j meters per second. I've just differentiated this thing up here by multiplying by the power and reducing the power by 1. That's how you do that. The way you can remember which way around to do it is you're going from displacement to velocity to acceleration. If you're going up this way, you want to differentiate. But if you're going the other way, you want to integrate. So here we're going from velocity to acceleration, you differentiate. This is how you remember which way around to go. And that's the answer because they just wanted an equation in terms of t. Question C. At time t equals 4 seconds, the position vector of p is I minus 4j, that's r. Find the position vector at 1 second. Okay, so now I've gone from v to a by differentiating. So how am I going to go back to r? I have to integrate. So nice and simple. Just going to save this. So r is going to be equal to the integral of velocity with respect to time, which, if you integrate this, increasing the power by 1 and dividing by the new power, is t cubed I minus 4t to the 3 over 2j plus c. C is going to be a vector as well. You need to remember this. Why? Because it's an indefinite integral. So we need a boundary condition to find c. In other words, they need to tell us a value for time and the displacement. Well, they've told us here. At t equals 4, r is that. So I'm just going to say at t equals 4, r is going to be equal to, and I'm just going to do column vector notation. So that would be 4 to the power of 3, which is 64. And this would be minus 4 times 4 to the power of 3 over 2, minus 32, plus my constant. What is that position vector equal to? 1, negative 4. You guys okay with me switching from ij to column vector? So this is what it looks like. in column vector notation. So therefore, C is just going to be equal to minus 63I plus 28J. If we just rearrange this for C. And I've just switched back again to IJ notation. So my equation for R, this implies that R is going to be equal to T cubed minus 63I. And then on my denominator, I'm going to go plus minus 4 T3 over 2 plus 28J meters. I need at time T equals 1 second. I need the position vector at 1 second. So at T equals 1, all I've got to do is sub that in here. So R is going to be equal to 1 minus 63I plus minus 4 plus 28J, which gives me minus 62I plus 24J meters as my answer. So I'm just going to explain what I've done again. So I need to find the position vector at a time. So to get from velocity to displacement, I have to integrate velocity. So I've just done that up here. And because I've done an integral up here, and the integral is indefinite, I need to have a constant, right? So that's plus C. How am I going to find that constant? I need a boundary condition. The boundary condition is just something they've told me. So they've told me that at T equals 4, that's the position vector. So I've just subbed that in. At T equals 4, R is going to be equal to 4 cubed, which is 64, minus 4 times 4 to the power of 3 over 2 is minus 32. I've just put that as I and that as J in column vector notation, plus C, which is that bit there, because remember, this is my equation for R without my C. Now this is my equation for R without my C still. But at that T equals 4, I know the position is what? 1, negative 4. So here, that is equal to 1, negative 4. So if I rearrange for C, in other words, subtract 64 from both sides, I get negative 63I. And I add 32 to both sides, I get plus 28J. This is my constant, which I can just plug back into my equation for R. R is equal to T cubed minus 63. Those are all my I components grouped, plus minus 4T to the 3 over 2 plus 28J. Those are my J components grouped, M meters. That's not the end of the question though. They wanted me to find the position vector at a certain time. So that's my equation. I just need to plug in T equals 1. So at T equals 1, if I plug 1 into this equation, I have 1 minus 63I plus minus 4 plus 28J. And that's what you get for the answer. So hopefully that makes sense. You're just working it through one step at a time and remembering that indefinite integrals have a constant. Let me just check the chat. Sorry, I've missed quite a few of the things. Sorry, does that explanation make sense, Adzi, with my re-explanation? The R equation is down here. This is my equation of R with my constant that I found. Only way I do, yeah, remember the plus C. Always remember the plus C in this. On my iPad, I'm using files. I'm just using a PDF for this because I've downloaded the exams, right? Good notes. Awesome. I will have to, I'm going to put a reminder at the top to check that out. Good notes. All right, cool. Makes sense. So what's the R equation though? Okay, so if the position vector with R naught, good question, C bar Depop. So that would look something like R equals R naught plus UT plus half AT squared. This is only for constant acceleration. The question we are dealing with in question 1 is variable acceleration, which is why we could not use this. However, this is just an offset for displacement or the position initially. So if, for example, you had your thing and they said that at time t equals 0, it's starting over here, which is, let's say, 2i and 3j, R naught would be 2, 3. You have to add that little offset if you found the movement from that initial position. That's how you do it. It's in the last chapter. Remember, add that offset if it does not start at the origin. Okay, that's how you remember to do that. This question is based on last chapter stuff. Yes. This is variable acceleration. All right. So the reason it is variable acceleration is because this t. That's your rule of thumb. If you see a t in the equation for velocity or acceleration, it changes as the time changes. Hence, it's variable. Awesome. So that is question one. Very nice start, in my opinion. Just work your way through it slowly. Make sure you're understanding what's happening, how to, if you're integrating or differentiating, plug in your values. I'm going to put this in red. Remember your plus C's so you know to find that constant of integration. Your hint would be when you're underlining the question, you wouldn't know that, hey, I've underlined t equals 4, that's the position. So you know you need to use that information. Questions for maths, generally, I found, they give you all the information you need and nothing else. So make sure you use all that information and nothing else. If there's alternative methods, then obviously you won't use it all, but yeah, nice 8-mark question there. This question, question 2, is something that pretty much almost guaranteed to come up. A slopes question. Just quick in the chat, how scale of 1 to 10, 10 being easy, how do you guys find slopes? So I know how fast to go. 1 being hard, 10 being easy. Why is constant acceleration there? This is a side note. That I was just explaining how this R naught works with constant acceleration. So yeah. 9, 5, 3.5, 7, 4. Okay, we've got a good mix. I'm going to go at a moderate pace then. I'm not going to go too slow nor too fast. And then I will check the chat after my thing, after I've walked through the question, okay? So this is how I would do it if I was seeing the exam. A rough plane, mu r, is inclined to the horizontal at an angle alpha where tan alpha is 3/4. I'm going to draw my triangle straight away, label it. It's a nice little Pythagorean triple. So sine alpha is going to be equal to 3/5, and cos alpha is equal to 4/5. A small block B of mass 5 kg is held in equilibrium on the plane by a horizontal force of magnitude x newtons. So I'm going to label here, I've got 5g, so I'm going to resolve that. So that bit is 5g sine alpha, because this is alpha, and this bit down here is 5g cos alpha. So far, I have just resolved my weight, parallel and perpendicular to the slope. Any other information? I've got that normal force there, so let's resolve that too. So I've got here, this angle here is going to be alpha 2. So this would just be x cos alpha. Why? Because it's adjacent, right? And going down, that's going to be x sine alpha. I have got a video on resolving forces too, guys, posted yesterday, so check that out after the live if that helps. All right, and cool, let's continue reading. The force acts in a vertical plane which contains a line of greatest slope of the inclined plane. This is basically just saying the diagram makes sense, right? This force is acting onto that block. It's not acting like around at an angle onto the block. Block B is modeled as a particle. The magnitude of the normal reaction is 68.6. So I'm going to label that as R, which is 68.6. Using the model, find the magnitude of the frictional force acting on B and state the direction of the frictional force. So this box is being pushed with this horizontal force. When it's a particle, that's a modeling assumption. So we can forget about a bunch of its properties. That's what particle means. Check out your chapter 8, that table. It has all the assumptions you need to know right there. Memorize that. Use flashcards if that helps. So it's a particle. So you've got a horizontal force pushing on this. Now, what I want you to do in that exam is visualize that you have got a slope and you have got a particle on that slope. If you are pushing that particle this way, is that particle going to go up the slope or down the slope? In this case, it's going to go up the slope. Friction, we know, opposes the direction of motion. So the friction is going to be acting down the slope this way. Friction. Okay, that's how you're going to logic your way through friction problems. Picture it. You can set up your pens and your sharpeners to visualize it too. That is my tip. So for part 1, I need to find the magnitude of the frictional force. So friction is going to act down the slope. So I'm going to just resolve parallel to the slope downwards. So This direction is going to be my positive. So friction, do any other forces act down the slope? This one, plus 5g sine alpha. Any others? Nope. This is acting in the opposite direction. So that's equal to x cos alpha. What do I need to find? Friction, right? I need to find what Fr is. I know this, but I don't know what x is. How am I going to find what x is? Well, they've given me this random information about the normal contact. So I'm going to resolve perpendicular to the slope. So resolving perpendicular, I'm just going to save this document so this doesn't go away. Resolving perpendicular, I'm going to take this direction is positive. So r, which is 68.6, is equal to, what else is perpendicular? This thing here and this thing here. So they are both going in the opposite direction to r. So that is opposing. So 5g cos alpha plus x sine alpha. What is that equal to? That's equal to r, which is 68.6, which is given in the question. So I will repeat what I've said, Adzi. So what I've done is I need to find what friction is, right? Frictional force. So friction is acting parallel to the slope. So I've resolved parallel to the slope. So friction is acting down the slope. What else is acting down the slope? This thing, 5g sine alpha. So they're acting in the same direction. They're on one side of the equation. That is equal to x cos alpha, which is acting up the slope. Because it's an equilibrium, they're equal. There's no net force. The net force is equal to 0. So I need to solve for this question, right? That's what for FR. I know what this is because I know what sine alpha is. I know what cos alpha is, but I don't know what x is. So how am I going to find what x is? X exists there. What other information have they given me? I've got this normal reaction force is 68.6. Notice, it's so important to remember the normal reaction force in this question is not 5g cos alpha because you've got another force pushing down onto it. So R is 5g cos alpha plus the perpendicular component of x, which is x sine alpha. That is equal to 68.6. I can easily solve this. So 5g cos alpha is going to be 39.2 because I do 5 times 9.8 times 4/5 up here plus x sine alpha. Well, that's 0.6x because sine alpha is 3/5. That is equal to 68.6. And now that just means that x, if I subtract 39.2 from both sides and then divide through by 0.6, I get x is a nice number of 49. Awesome. So I found x, which means that I can resolve down the force and resolve down the plane and find friction. So friction is equal to x cos alpha, which is 49 times by 4/5 up here. Subtract, I'm going to subtract this in this step now. Subtract 5g, which is 9.8. Sine alpha is 3/5. And that is equal to 9.8 newtons. Funnily enough. So your friction is 9.8 newtons. That's how you do part A1. For part 2, well, we already answered it while we were logicking it through, right? So for part 2, it is going down the plane. The reason it's going down the plane is because remember I said visualize you pushing that up. It is going to go up the plane. Friction opposes the motion, so it's going to go down the plane. The reason for part 1, I just need to point out, they say find the magnitude. If you get a negative answer here, they accept both positive and negative 9.8 because they just want the magnitude of it. However, down the plane, this is where they're asking for the direction. So if you assumed friction acted in the wrong direction, you just get a negative answer, but it's all good. You just need to know the direction for part B. Let me just check the chat. Beautiful question. Yeah. This one's actually all right. It is. What does it mean by yeah? So the magnitude. Does that explanation make sense, Adzi? It just they don't care about the sign. They just care about the number, size, basically. Exactly. So if you assume friction was acting in the wrong direction upwards, and you got a negative answer, they wouldn't care. The magnitude is just the size, 9.8. So that is part A done. Part 1 and 2. Part B. So the horizontal force of magnitude x newtons is now removed and B moves down the plane. Given that the coefficient of friction between B and the plane is 0.5, so that's mu, find the acceleration. All right, we see the word acceleration and stuff. We know we're going to do something with F equals ma. So what I do in this is just draw the new diagram, make it completely clean because, guys, let's be honest, this is very messy and hard to work with again. So fresh question, do a quick sketch, do your line, do your particle, And now just label the important forces, okay? So I'm just going to label the forces that are parallel and perpendicular to the plane. So I've still got a normal reaction force of 5g cos alpha this time. Remember, I have removed this force. So the normal reaction force is just going to be equal to this. That's alpha. And I have my parallel component of the weight, because there's my 5g alpha, 5g sine alpha. And now they tell me it's moving down the plane. So I've got acceleration downwards. If the thing is accelerating downwards, that means the friction is going to be upwards. Mu r, because friction opposes the direction of motion. Let me just check the questions. Yes, it would be smart to redraw the diagram. Just so you know, because those forces are gone, r is completely different now. Can we draw a diagram in the exam before we show working? 100%, 100%. But make sure you do diagram and you're working, yeah? You're allowed to do a diagram before you show you're working. So if you wanted to redraw the diagram over here and then do the working for part A, do that. And do, like, yep, as Bryn says, definitely do it. It will make it much clearer. Awesome. So they love seeing diagrams. It makes it much easier to understand what you're doing. So I need to go down. So now is going down. The friction acts up. And we need to use that r is 5g cos alpha, which we've put on the diagram. So if I'm resolving downwards and using F equals ma, I need to find acceleration, right? So if F equals ma, F is my resultant force. So I'm going to resolve down the slope. So 5g sine alpha and mu r are the only two forces parallel to the slope. So I'm going to take downwards as positive because it's accelerating downwards. So 5g sine alpha stays positive, but friction is in the opposite direction. So we subtract that. Mu r is going to be equal to m. What is the mass? Well, they told me 5 kg. 5 times by acceleration. If I rearrange for acceleration, I get acceleration is 5 times by g, which is 9.8, sine alpha, which was 3/5 from the earlier part of the question, subtract mu r. What is mu? Mu is a half. And what is r? R is 5g cos alpha. So that times 5 times 9.81 and 9.8, sorry, and cos alpha is 4/5. That's a 5, and I'm just dividing through by the mass in this step. So I've just divided through by 5, 2, and subbed it. And if you put that in your calculator, you get 1.96 meters per second squared to 3 significant figures. Or I think that is the answer, yeah. And that is 6 marks in the bag just for this bit of working. It is a beautiful 6 marker. I hope you guys get a 6 marker like this. You guys are going to be over the moon, in my opinion. So does this make sense for this? Let me just check. Thank you for the gift, Oliver. I really appreciate it. Yeah, you're allowed to do anything you want. Awesome. So that is how you do a slopes question. That's 6 marks. Yeah. Just remove the x and work out. Yep. Long story short, remove the x, work out as normal. We use, yes, exactly as we use F equals ma because they want us to find acceleration. How do we find acceleration? The only thing we know to do with that is F equals ma. So we resolve to find the F. We know the m. We want the a. That's how you do it. And yeah, rule of thumb for all that. And make sure when you're finding the F, you add components and subtract the components in the opposite direction. Beautiful. I love mechanics. I love that question. My favorite types. Question 3. This question, without going into too much detail, this is a vectors question. You need to be very, very good at vectors. A particle of mass 4 kg is at rest at point A on a smooth horizontal plane. The fact that there is a mass given has me thinking I'm going to deal with weight or F equals ma. That is just a bit of, foreshadowing. At time t equals 0, two forces, F1, which is that, and F2, which is that, notice lambda and mu, are applied to P, where lambda and mu are constants. So, given that P moves in the direction of the vector 3i plus j, so that's the movement of it, okay? Not the position. Show this equation. Basically, they want me to find that equation that solves lambda and mu. Let me just check the chat before we get into this. Lambda, yep, exactly. Scalar, it is constant. Lambda and mu are just representing constants and even stats, right? Because you use lambda is not used for normal stats, but for further stats, for the Poisson distribution. But mu is used as the mean. That's what that represents. So these are just scalars. Don't be put off by them. They're just a number. They're just, instead of x, y, z, or a, b, c, they use lambda and mu. So show that this equation. Well, the only thing I really can do is find a resultant force. That's the only bit of working I can do based on the information given. So Fr, which is my resultant force, is going to be equal to F1 plus F2. Remember, if the forces are given as vectors, just add them. The directions are already considered. So thus, I like to do it in column notation. 4, -1, plus lambda I mu j. That is just simply equal to 4 plus lambda and -1 plus mu. So I have just found the resultant force. This is a force pushing this particle and is pushing it in the direction of 3i plus j. So I know that 4 plus lambda and -1 plus mu is going to be some scalar of 3 and 1, 3i plus j. Now, the t is just like lambda and mu, in that it's a scalar. T is just a scalar, just representing any number. That's why I put a t there. So I can just equate the equations and see where I go from there. So I have 4 plus lambda equals 3t as my first equation for my i's, and now my j's is -1 plus mu equals t. Now look at the question. They want an equation in terms of lambda and mu without any t's. So if I just rearrange for t here and t here, I can equate them, and then I'll just have an equation with lambdas and mu's, which is what I want. So dividing through by 3, I get t is 4 plus lambda by 3, and t is already given there. So if I just equate them, I get 4 plus lambda by 3 is equal to -1 plus mu. Does that make sense what I've done here? So all I've done is say that there's another scalar here because it's moving in the direction. Direction means use a scalar. I've just used the letter t. You could literally put anything you want. You could put that, you could put that, you could put that, anything that's not been used. So it's moving in that direction. Equate your I components, equate your j components. The equation has no t. So I've just made them equal in terms of t. If I rearrange and multiply across by 3, so I get 4 plus lambda equals -3 plus 3 mu. And what is it? Oh, all of them are on one side and it's equal to 0. So bring everything onto one side. Therefore, I have that lambda -3 mu plus 7 is equal to 0. That is how you do that part A of the question. Does that make sense, guys? I'm going to show you an alternative method to this now as well. So you could also just, if this t scalar bit, if you don't know that, you could just say, oh, the movement of I to j force is in the ratio of 3 to 1. So you could just say that ratio of I to j is just 3 to 1. So 4 plus lambda is my I movement to my j movement, which is -1 plus mu. That is equal to a ratio of 3 to 1. So then if you multiply across, you have 4 plus lambda equals -3 plus 3 mu. And now look, we get the same thing. So both of these methods are acceptable. I like to use scalars whenever something is moving in a direction of it. But yeah, that's how you do this sort of mechanics question. This one, it doesn't tell you what to do annoyingly, right? I hate the questions that don't tell you what to do. So just see, what can you do with the information given? Resultant force. Find that, then continue, all right? So that is how you do part A. Hopefully that makes sense for everyone. So part B, at time t equals 4 seconds, P passes through point B. Given that lambda is 2, find the length of AB. So this is 5 marks. I've been given, second method is nicer. Yeah, the second method is nicer. It's just knowing ratios. So I've been given 2 pieces of information. I know what lambda is. So if I know what lambda is, I'm going to find mu. So B. If lambda is equal to 2, then t is going to be equal to 4 plus 2 by 3. I'm using this equation over here. So t is going to be equal to 2 because 6 by 3 is 2. So if I plug that into this equation for mu, I get that mu is equal to t plus 1, which is 2 plus 1, which is 3. So therefore, lambda equals 2, mu equals 3. I know what that force is. So my resultant force is going to be equal to, and if I go up on the question where I've labeled that, that's 4 plus lambda and minus 1 plus mu. So 4 plus lambda is just 6, and minus 1 plus 3 is just 2. That is now my resultant force. Awesome. So, yeah, I'm seeing F equals ma, which is exactly what we were thinking. Remember, I told you they gave us a mass, so that's foreshadowing. We need to use some F equals ma in SUVAT. So, SUVAT, exactly. So we need to use both, actually, because we want to find a length, right? That's S. So, how am I going to find a length? SUVAT, I need A, so I could find my acceleration. So, if F equals ma, F, which is 6'2", my resultant force, is equal to the mass, which they told me at the top of the question was 4 kg, times by my acceleration, which means that my acceleration as a vector is going to be equal to 3 over 2 and 1 over 2 meters per second squared. Does that make sense? How is mu equal to t plus 1? Because over here, with my scalar bit, I have minus 1 plus mu equals t, so mu is equal to t plus 1. Awesome. So I found my acceleration. Now I can do SUVAT. Exactly. So write down your letters, S, U, V, A, and T. Trust me, it makes it so much clearer. So from A to B, I'm trying to find a distance. That word distance tells you you have to use SUVAT. So if it's distance, I want you to think of two things. Either speed equals distance divided by time, or SUVAT. You use this if you've got an acceleration, and you use this if it's a constant velocity or speed. You've got an acceleration here, so you know you need to use SUVAT. That's how you'd approach this question. So my displacement is what I want. My initial velocity, well, they told me it starts at rest, which is quite useful. So u equals 0. Which random, where did FR come from? FR is the resultant force. Resultant force. I just use FR for note. So I've just added those two. All right. What is V? I don't know what V is, but I know my acceleration right there. That's 3 over 2 and a half. So I'm just going to find the magnitude of the acceleration. Therefore, the magnitude of the acceleration is the square root of 3 over 2 squared plus a half squared. That's going to be equal to square root of 10 over 2 meters per second squared. And my time, well, what is my time here? At t equals 4 seconds, it passes through B. So time equals 4. Is that making sense, everyone? Which is the method on the left with speed? This is just speed equals distance over time. You use this if there's no acceleration, and you use this if there is an acceleration. That is the difference between these. So when you see, if they want you to find a distance, these are the two things you think of: speed equals distance over time, and SUVAT. If you've got an acceleration, use SUVAT. If there's no acceleration, it's constant speed, so speed is just distance over time. So distance is speed times time. Awesome. So now, looking at this, I have S, U, A, and T. What equation links them all? S equals UT plus half AT squared. So now I'm just solving for S. So I just sub in U is 0, so that goes away. So a half times by A, which is square root of 10 over 2, times by T squared, which is 4 squared, just gives me 4 root 10 meters as the distance it travels from A to B. Let me just check. Why do I do Pythagoras? So A here has been given as a vector, right? 3 over 2 as my I component and a half over there. So because I want to find SUVAT, I want to just use the magnitude of the acceleration. So I just use Pythagoras. It's just the magnitude. Exactly, Mark. Exactly. So making sense so far? We good with this? And I think, yep, that's it for this question. So this one doesn't really tell you what to do. This one is more of those open-ended questions where you need to figure out what to do. And hopefully those tips I gave you when we were working through this, you will now know how to approach questions like these when you find stuff. So for the first one, find the resultant force. That's the only thing you can do. The second one, finding a length. Okay, you're thinking distance. So you want to either use SUVAT or speed equals distance over time. Well, the particle is accelerating, so you're going to use SUVAT. How do I find the acceleration? Use F equals ma. I don't know the force. Well, I know what lambda is. So for lambda, you see how we work backwards from that? But yeah, that's how you do question 3. Awesome. We're going to do question 4 and then question 5. We're ending on a nice projectiles question, which I love. So Let me just check. Is everyone all good so far? Let's just focus on being better. Exactly. Focusing on what we better than yesterday. So, question 4. These are the ugly questions. Let me know your thoughts on this question. Do you guys like this question or do you not? Stats is better than mech. Oh my god, that's crazy. I have never seen anyone say that. Love this question. It's okay. This is the kind of question that'll get me. Good question to be fair. Okay. Okay, so I'm going to tell you exactly what to do when you see this question. Because when you see this question, I don't want your mind to go blank, okay? There are two things to do when you get an applications of forces question. The two things to do are, and I'm just going to put them up here for future reference, are either taking moments or resolving forces. And I'm going to tell you which to use when. The video I posted about this as well, I've done a couple of videos similar to this, will tell you how to do it. The one I posted on hinges today works through similar example to this too. And also the one where I'm setting up a tent. So we're going to do this question and you're going to see it's actually not too bad. This topic is the applications of forces question. So it's the yellow color, I think it's unit 7 in year 2. So a uniform rod AB has mass m and length 2a. It's uniform, which means that the mass acts at its center, and its length is 2a, so I can label that on. So here, my weight, which is the force, is mg, and it acts at 2a. So this is going to be a here and a here. A particle of mass 2m is attached at point C, where AC is 1.5a. So that is AC, and that is just 1.5a. And what is the force acting here? 2mg. Making sense so far? I will look at the chat, by the way, after I do this question. The rod rests with end A on rough horizontal ground. To remember the ground is rough, I like to do this on the ground, just to show me it's rough. If it's rough, there's going to be friction, so just keep that in mind. The rod is held in equilibrium at an angle theta to the ground by a light string that is attached to end B of the rod. So it's in equilibrium, which means that the net force and net moments are both 0. The string is perpendicular to the rod as shown in figure 2. Yep, so that string is perpendicular. It exists. Explain why the frictional force acting on the rod at A acts horizontally to the right on the diagram. So I got a few more things to label here. So I know that the friction they've told me is acting to the right, so there. Because the rod is touching the floor, remember, if two surfaces are leaning against each other, like this pen is against the screen, there's going to be a reaction force. So I'm going to label my reaction force over there R. I've got a string here. Remember, you see the word string, you think there's a tension. This tension is pulling it upwards, right? It's pulling it upwards, so the tension goes up. Now, why is the friction acting to the right? I'm going to look at this diagram and see forces that are acting horizontally. So I've got the friction acting here. This is not horizontal, that's not horizontal, but the tension has a horizontal component. It's acting this way horizontally and this way vertically, right? So we can just say as our answer that part A, the rod is in equilibrium, right? Which means that the forces must be balanced. The horizontal component of T acts to the left. And since the only other horizontal force is friction, it acts to the right to balance it. Because we know that the resultant force in any direction is going to be equal to 0. Just screenshot it. All right, so the resultant force in any direction is 0. So I just looked, what are my horizontal forces? The horizontal part of T there, and friction. So they have to both oppose each other, hence friction acts to the right. So that's how we do part A. Part B, the tension in the string is T. Wow, so useful, guys. Show that this is the tension. Now, this is where the question gets a bit hard. How do you know what to do? There are two things, like I said, you do with this type of question. Either you take moments or resolve. Now I'm going to tell you how to know which one to do, and it is going to make these questions so easy for you, hopefully. Well, if you know what to do. So you take moments if you IDK forces at 2 points. If you don't know forces at 2 points, exactly, I like what I'm seeing in the chat, moments about A. So if you don't know forces at 2 points, you want to take moments. You'll take moments about one of those points so you can forget those forces, then find the forces at the other one. Moments confuse me? Okay, I'm going to try and explain it as clearly as I can then. You resolve if IDK forces at 1 point, because then you can just resolve horizontally and vertically, and then you'll have, your answer. So that's what you do. That is your rule of thumb. Remember that for these questions. This is super important. Check out my TikTok on this type of question as well. I walk through how to do this. So, because, now tell me in the chat, how many points do I not know forces at in this diagram? Ignore that blue line. How many points do I not know forces at in this diagram here? Let me know. 2, exactly. So I'm going to take moments. The reason I'm going to take moments is because I don't know forces at this point here, and I also don't know the forces at this point here, because tension is not given. How do you know the angle of tension is acting vertically horizontally? Well, you can see that tension is going off at an angle here. So some part of the tension is acting this way, and some part of the tension is acting this way. That's how you do that, okay? It's always about A for exactly. Most of the time it would be about A. So, part B. We want to find tension, IDK the forces at A. So we're going to take moments about A. You could also take moments about T to find the forces at A. However, we want to find what T is. So why would we do that? So if we take moments about A, we can forget these two forces. They don't become a problem for us. Hence, we do that. So this rod is in equilibrium. mg is a force. It is a force. However, that's just, we know the force at that point, mg, right? And 2mg is also a force. So this rod is in equilibrium, which means that the sum of the clockwise moments about A is equal to the sum of the anti-clockwise moments about A, okay? Now, I'm going to teach you how to know which forces cause a clockwise and an anti-clockwise moment. So, if you guys have a pen with you, take a pen out as well. This is your pen. The pen is going to represent this rod. So, hold your hand like a hinge or like a little pivot here at A. Okay, that is where we're taking moments about. These are my 3 forces. We need to see which ones are clockwise, which ones are anti-clockwise. So, mg. This is my mg force. It is going downwards. If I imagine that mg force pushing down, you see my pen is rotating clockwise. So this force produces a clockwise movement. Same thing with 2mg. The 2mg force is going to be up here. I push it down in the direction, clockwise movement. Now the tension. This tension is going upwards this way. So if I'm holding onto this and I'm pushing this up, notice we're going anti-clockwise. So this is my anti-clockwise force. These are my clockwise forces. So that is how you figure out which forces cause which movement. Trust me, modeling it with your pen is so, so useful. So the way you calculate a moment, the formula I'm going to write on the side, moment is force times by the perpendicular distance from the line of action of the force. That bit is a bit weird, so I'm going to show you with the diagram. So the force, I'm going to start with my mg over here. So the force on that is just mg. We're happy with that. mg. Now, the distance, I need the perpendicular distance from that force. So I'm going to do it in blue. Imagine I extend this force like this. Like this is the line of action of that force, right? We agree is going vertically downwards. The perpendicular distance, I'm just going to draw a line going at 90 degrees at that, is this thing here. You see, that is my perpendicular distance. That is how you figure out which distance you want. So you visualize the line being extended, draw perpendicular to that line, and wherever it goes, that is that distance that you want. So if I draw that triangle out over here, this is the distance I want. This is like where the mg is acting. This is theta from the question. Do I know what this length is up to mg? I do. It's A because it's a uniform rod. So that is going to be A. So what do I need? I need the distance x. So that's adjacent hypotenuse cos. So cos theta equals x over a, which is just multiply out, you get that as your perpendicular distance. Let me know in the chat if that doesn't make sense. Hopefully it does. So I'm going to continue going unless someone stops. That's going to be a cos theta. So that's the force times by the perpendicular distance. We're going to do the same thing for the other clockwise force, which we said was this one, right? So that's the force. That's the line of action of the force. So this is going to be the perpendicular distance. Notice we're doing the same thing, except A is now going to be this distance here, which is 1.5a from A to C. So plus the force, which is now 2mg. Just going to save my document. Times by the perpendicular distance, which now is just 1.5 on this bit. So it's the same thing, 1.5a cos theta. That's how you do that, all right? Now, that's all my clockwise moments summed together. My anti-clockwise moments now. What is my anti-clockwise force? The tension. What is the perpendicular distance? For this one, imagine if I extend that. Notice the perpendicular distance is just this distance here. So the distance is just the distance of the rod, which they tell me is 2a. So that's the force times by the perpendicular distance right there. Is that making sense so far? This is not GCSE, don't worry. If this was GCSE, it'd be crazy. Where has the mg come from? The mg is the force. Remember, that is the force. The force is this one here, and this one here. So for that one, mg is the force acting downwards. The T2a, so the force is tension, right? Now I'm focusing on that force. What is the perpendicular distance? Imagine you're extending it and draw a right angle to join that and your pivot point. This is the distance, right? That is just the distance of the rod, right? So what is the distance of the rod? They tell us it's 2a. So it's force, which is T, times by the distance, 2a. That is how you do that. My live will be on my YouTube if you want to watch that section again on how to find the perpendicular distance. Visualizing and drawing on really helps, all right? So I'm just going to cancel out my a's because I don't want them. They all go away. So now if I just rewrite this, I get mg cos theta plus 2 times 1.5 is 3 mg cos theta equals 2t. The question told me I want to find tension. So I just have to rearrange for tension. So if I add mg cos theta and 3 mg cos theta, I get 4 mg cos theta. Is looking good so far, guys. Then I divide through by 2, and therefore tension is equal to 2 mg cos theta. And that is how you do part A. B of this question, and you get a nice little 3 marks. It seems like a lot of work for 3 marks, but what I did was I went through it kind of slowly, explained how we did each part, how we found the distances, how we knew what to do. So remember, this is what you're going to think when you get a question like this. This is your life hack. This is your hack for the type of questions. Moments. If you don't know the forces at 2 points, you take moments. If you don't know the forces at 1 point, you resolve. Then you take moments about the point where you don't want to find the forces. So I don't want the forces at A, I want the forces at B for tension. So take moments about A, then just do your force times perpendicular distance. Do these triangles. This is going to help you out when doing it because you can clearly see what you want and do a bit of trig there. Awesome. How was that? Did that make sense for everyone? Did that kind of help clear things up? Why don't we want forces at A? Well, because the question told us we want to find the tension, right? The question is asking for the tension. On my diagram, the tension is at point B. So I don't care about the force R or the friction at point A for this part. That's why I've done moments about A. You do moments about the point you don't want the forces at. So for that one, I don't want that. It's more the MGA and the 1.5. What is it? That loses me. Yeah. Initially, when I was doing moments, that kind of lost me too. But if you just do the thing I told you with the extending the line and drawing a perpendicular line from that line to the point, that will help you see. Then you can see that, oh, that's A, that's that. I want this distance. I just do a bit of trig. That's how we do that. Just go away. Get rid of that. Okay. I'm still a bit confused about the mg being times onto the trig bit. So the reason, that is just the equation for a moment, because moment is just equal to the force, which my force here at this point is mg, right? Weight, mass times gravity. is equal to the force times by the distance. Now, if you want to visualize that conceptually and actually understand what a moment is, imagine you're opening a door, okay? You've got a door handle. The thing you're taking moments about is going to be the hinges on your door handle. You open the door, like imagine you're pulling that outwards. You're pulling it with a force, right? That force is causing a rotation movement of that door because that door is like rotating outwards. The distance is just the distance from your handle to the hinge, which is a perpendicular distance. That is why a moment is just the force times by the perpendicular distance from the line of action of the force. So yeah, mg is not the opposite side of the triangle because it's a weight, not a distance, but it acts in that direction. That's how you do that. Awesome, cool. Part C and D. There's still a bit more to go. This is a very big question, but C and D should hopefully be easier since we know what to do now. Given that cos theta is 3/5, what am I going to do straight away? I am going to do my little triangle. So that is going to be 3, that's going to be 5, that's theta. So sine theta is going to be equal to 4/5. Most of the time you don't need tan theta, but just write it out. It takes you less than a second. Boom, tan theta is there. And show the magnitude of the vertical force exerted by the ground at A is this. So what am I finding here from my diagram? This thing. I'm trying to find R, which is my vertical force. Get rid of that. R. So let me just check the chat. Why is there no reaction at C? There is a reaction. No. Why is there no reaction at C? Well, because you've got, where is it? Where does it talk about C? A particle is just attached to that point. It's not actually sitting on that point. It's like attached to the rod. And we should know that a particle can just be attached to the rod. Hence, it's like there's no force on it. So, if it was like a log over there, there would be a reaction, and I have a video exactly like that. But this one is attached. It's not resting against it. Hence, there's no reaction force there. So, I need to find the magnitude of R. Now, I know forces at this point, and I know the tension. So now I just don't know the forces at one point, which means I can resolve. That's how you do that. Yeah, so if it's attached, there is always no reaction if it's attached. If it's resting or leaning, there is a reaction, right? Because reaction force comes if two things are in contact with each other. Here's like just gripping on, right? I'm gripping onto this. There's not going to be really a reaction force there if we're assuming the modeling assumptions. So for part C, what do I want to find? I want to find R. R is acting vertically, so I'm going to resolve vertically there. So resolving vertically, taking upwards is positive. R, what else is vertical here? The vertical component of T is also going up, and these are in the opposite directions. So this is going to be my this is my horizontal component of T. This is my vertical component of T. The way I do it is I like to just say that this is also theta because alternate angles with that. So this would be 90 minus theta. I do it with, trig, sine and cosine relations. That's how I find it easiest. So I'm going to add this bit. What is this vertical component? That's opposite. So this would be T sine 90 minus theta. That's the vertical component. So plus T sine of 90 minus theta. And that is going to be equal to the downwards forces. What are my downwards forces? mg and 2mg. So my downwards forces is just going to be equal to 3mg. Now, I know what tension is because I just found that in part B. So R plus 2mg cos theta. Sine 90 minus theta, remember, is just cos theta. So I have cos theta again equals 3mg. Now I'm solving for R. So R is going to be equal to 3mg minus 2mg cos theta. I figured it out, or I've been given it as 3/5. So I'm just multiplying by 3/5 squared because I've got 2 cos thetas. And that gives me an answer of 57/25 mg for R. And it's a show that question. So have I written it the correct way? Yup. I could just like extend my little fraction to make sure that there. And that is how you do that. Yep, I did form another triangle at T. this one. So this is my triangle at C. So if I just draw that out separately, you've got the tension acting there. So you've got the horizontal component and the vertical component. That angle, well, I know it's 90 degrees and that's theta. So this is 90 minus theta, 90 minus theta. So for that one, that's tension, that's opposites, that's T sine 90 minus theta, and that's T cos 90 minus theta. Wait, explain that last step. Sure, the last step, let me just go down. So this last step, I'm going to walk through this. So I've resolved, this is my vertically upwards and this is downwards. I've just substituted in my t value there, 2mg cos theta. And I've changed sine 90 minus theta is just cos theta. You need to know this relationship. And cos 90 minus theta is just sine theta, like that. That's cos theta. That's equal to 3mg. So I've just subtracted this big thing from both sides. So I get 3mg minus 2mg. Cos theta times cos theta. Well, they told me the question cos theta up here is 3/5. So I multiply that by 3/5 squared. That is equal to 57 over 25 mg. Just multiply that through. Yeah, it is a bit weird that I did 90 minus theta. Just that's how I find it most comfortable. If you guys do other methods for doing that triangle, do that. Do what you think is easiest. This is how I've logicked it through. But yeah, what trig relationship do we need to know about? What trig relationship do we need to know? Acute angles. It's just the translation, right? Because you know that if a sine graph looks like this, a cos graph is basically just a translation that way by 90 degrees. So cos of 90 minus theta equals sine theta, and sine 90 minus theta equals cos theta. Just know these relationships to use the method I use. That weird triangle thing I do, I just use this relationship. You can also skip the middleman, skip that middle step, but that's how I do it. So yeah, you can Google, and if you don't trust me, I don't even trust myself. Before my exam, I would just find Google, is cos 90 minus x equal to sine x, and just see what the equations are given there, learn those. Awesome. That's how you do that. We are still not done with this question. The coefficient of friction between the rod and the ground is mu. It is in limiting equilibrium. If it's in limiting equilibrium, we know we've got maximum friction. Show that mu is equal to 8 by 19, 4 marks. On this entire question, they have given me the answers, guys. Even in this part, they've given me the answer. So if you get this, you know you've guaranteed how many marks? 7, 10, 11 marks. So let's try and get these last 4 marks. So limiting equilibrium. I don't know forces just at one point, right? But this one, I'm just trying to resolve horizontally because this mu appears in the friction equation. That is in the horizontal plane. So I just look, what are my horizontal components? That and this part of tension, right? Because tension acts at an angle. So that is not what I want. Let me just scroll down. For part D, resolving horizontally, like I said, we've just got the friction is equal to T cos of 90 minus theta. Remember from part A, it said friction and the horizontal component of tension, we said they oppose each other. This is why. So friction, the equation for that is mu times the reaction force. T is, I'm just going to call that T still. Cos 90 minus theta, remember that's just sine theta because of the way that the sine and cos graphs shift. So I'm solving for mu. So mu is equal to T, which is 2mg cos theta, multiplied by sine theta, divided by R, which is given over here, which I've solved, 57 over 25 mg. Notice my mg's cancel, which is good because I want a value, not an algebraic term. So I'm just doing 2 times cos theta, which is 3/5, times sine theta, which is 4/5, divided by 57 over 25, and that is equal to 24 over 25, divided by 57 by 25. And then these things cancel. You get 24 by 57, which is equal to 8 by 19. And that is your mark for mu, and that is 4 marks in the bag. I don't know why the last part is worth 4 marks if that requires the least amount of work, but that is how you do it. So, do these types of questions make more sense? I will post this live as soon as I can on my YouTube channel, but yeah, whenever you get an applied forces question, 2 things to do: moments and resolving. If you don't know if you don't know the forces at 2 points, you take moments, And if you don't know the forces at one point, you resolve, and you go like we did. What is this? This is applications of forces. Exactly, that's what I'm thinking. Why is the last part worth 4 marks? That should be worth 3 marks. This should be worth 4 marks, and these should be worth 4 and 3 or 3 and 3, in my opinion. Y t sine x. Where is that? T sine x here, right? Because I'm saying that t cos 90 minus theta is just sine x. Why is friction equal to that? Well, look at part A. Remember, why is the frictional force acting horizontally to the right? Why am I trying to slide on my monitor? So the rod is in equilibrium, right? The horizontal component of the T acts to the left. Because look at this diagram. What are my other horizontal forces? This is horizontal. That's not. But this is at an angle, so it's got that horizontal component there. So that is equal to that because they're in opposite directions and it's in equilibrium. And yeah, why is friction equal to T sine x? Because I said that, yeah, I just explained that, right? Because that, yeah. Awesome, cool. Now, I want you guys to not hate this question when it comes up. I'm hoping my explanation made sense, the way I logicked it through and showed you the tips on where to start and how to get the marks. Let me know in the chat. Is this looking more good? Hate this question, yeah. But is it kind of making more sense than when you first started them? Like, when you see this, you're now going to know, hopefully, what to do, right? This. Have a TikTok on this. Watch the TikTok, see how to do. I'm still going to hate this. Okay. But do you understand it now? I love it. I want O level where you get to pick. Oh, did you add? Oh, yeah, you did. Yeah. All right. Glad it helped. Awesome. That only the main thing is you're still going to hate it. I just want you to understand it. If I memorize, don't memorize papers, but memorize methods. Memorize methods because mechanics tend to be similar every year. But don't memorize papers. Memorize what you've done. So here I've memorized that I've taken moments and I've done resolving forces. For this type of question, I've memorized that, oh, I need to resolve forces and do suvat, and so on. For this question, I've memorized how to resolve on a slope, and this question, I've memorized how to go between displacement, velocity, and acceleration, and so on. Yeah. Bum, bum, bum. Oh, no. All right, come on. 1 or 2 more days for you guys to push. Then you're all good. All right? Yeah, the question is never going to be identical. Exactly. They're going to seem identical in the sense they all use algebra, but they are not. And there's always going to be some nuance that's changed. Good luck to all A-level students. Yep, thank you so much, Ishan. Appreciate it. I don't do anything. I just go into the hall with a pen and a dream. Yeah, dream that you pass, man. All right? Just keep pushing for these last few hours, last 48, 56, 24 hours. All right, cool. That is how you do this question. I will post this live so you can rewatch it. I'm getting a bit sad now. This is the last question we're going to do together before you guys sit your final exam. But it's a projectiles question. I love projectiles questions. The people in the live yesterday love projectiles questions. I take a calculator too. I am not an A-level student. I did my A-levels last year, so I am a uni student now. Awesome. I love how Vin is answering for me too. Projectiles. Heard of them, never did them. Okay, no worries. There's only one difference. Projectiles is basically double suvat. You're doing suvat horizontally and vertically. But you know that horizontally, there's no acceleration. So that is just a speed, distance, time calculation. And I'm going to show you exactly how to do that. I will be posting it on my YouTube channel. It's got the same name. So follow my TikTok and my YouTube to have them both there. It's not going to be on my TikTok, but you know, I'd appreciate the follow, guys. Shameless promotion. But yeah, it's on my YouTube channel at I'm a user, or you just search a user and I should come up. Love projectiles. So do I. All right. Last question we're going to do, then I'll give you some advice. You can ask me any questions or clear any doubts if you have with what we've done so far. And you can feel free to message me on DM me on my DMs on TikTok. I will be up. I tend to be up kind of late, around midnight or 1 a.m. So I'll keep my phone on and respond as fast as I can to you guys if you have any questions. Okay? And don't worry, I won't judge you even if you ask me questions you think are dumb. So, question 5. This is going to be The last question of the live season 2025. Okay, ending on a very nice well, it's not a very nice question. Apparently, this is one of the harder projectiles questions, which is good. Okay, because projectiles guaranteed pretty much to come up. If they don't, that is going to be one of the biggest wild cards at Excel will throw at you if you have no projectiles question. So, a golf ball, why is it? Yeah, a golf ball is at rest at the point A on horizontal ground. So it's at rest initially. The ball is hit and initially moves at an angle alpha to the ground. The ball first hits the ground at point B where AB is 120 meters, shown in the diagram. The motion of the ball is modeled of a particle moving freely under gravity with an initial speed of u meters per second. So this would be u meters per second. Notice u is acting at the angle. Using this model, show that u squared sine alpha cos alpha is equal to 588. This is worth 6 marks, big chunk of that paper. Now, they have not told you what you need to do. So how are we going to go about doing this? My tip, when you're doing projectiles question, write everything for the horizontal and vertical components and go for there. You want to make an equation with u in, okay? So, part A, I'm going to do my vertical motion and I'm going to take upwards as positive. I'm doing motion for the entire movement, okay? Because I've been told the entire distance, and I don't know the maximum displacement there, so I don't know that value, but I know that it goes back down to 0, right? That's my overall displacement. So vertically, like I said, displacement is 0 because it goes from here to here. The distance from the start to the end is just 0 upwards. My initial velocity vertically is going to be u sine alpha. The reason it's u sine alpha is because the speed is at u. It's at an angle at alpha. This is that vertical velocity. Can you put, yes, you can put the distance at 60 if you're going to go halfway between the thing. Then you can know that the v up there is equal to 0, the final velocity. You can do that as well. I'm doing the whole motion because that's what I picked, but you can do both. So the vertical component of the velocity is that thing there. That's opposite, so it's just u sine alpha. My final velocity, I don't know that at the end for the whole motion, so I'm going to put a note up here. This is the whole motion for reference. My acceleration, I've taken upwards as positive. Remember that if I'm going up as positive, the acceleration is acting vertically downwards. So A is equal to minus 9.8 meters per second squared. And I have a time. Do I know the time? They haven't given me any information for that yet. Well, told me what the time was, so I don't know that yet. Can you put max distance at 60? Does that always apply? Do you mean like does the final velocity vertically always equal 0 halfway? That is at the maximum point. So at the maximum, which occurs halfway because it's a parabolic motion, right? And this is only if it's launched from ground level. If there was a bit of a height, then your max height would just be there, okay? So it's going to still happen at 60. So here, if you take 60, your final velocity would be equal to 0, and you would go from there. You can do that too. No worries. No worries, Aisha. All right, cool. So I don't know my V and I don't know my T. Now I do my horizontal, because remember, with projectile motion, do both vertical and horizontal. You should know that horizontally, there is no acceleration. So it is a simple speed equals distance divided by time question. So my displacement horizontally is 120. Don't confuse S with speed. S is here displacement. My initial horizontal velocity, which is also my final, is this part here, right? That is adjacent to the angle. So that is u cos alpha. And the time taken, well, I can easily find the time, right? Because if speed equals distance divided by time, time is going to be equal to distance, speed divided by distance, distance divided by speed. Here I am mixing it up. So time is equal to distance divided by speed, which is 120 over u cos alpha. So that time is 120 over u cos alpha. Now, this is a projectile, right? The horizontal time, the time it takes to move horizontally, is also the time is going to move vertically. We are doing both. We're doing horizontal and vertical motion because the question hasn't told us exactly what we need to do. Always write out both. That is my tip for projectiles. And you can refer to it throughout the rest of the question. So this time and this time are going to be equal, quite obviously, right? Because it's in the air for the same amount of time. Awesome. So now there's nothing else I can do with my horizontal motion, so I'm going to forget about that and look at my vertical. I've got S, U, A, and T. I can make an equation with S, U, A, and T. So what equation is that? That is S equals, let me just save this real quick, UT plus half AT squared. You have to have this memorized by now to make it easy for you. If you don't worry. It's also in the formula book. But I don't want you guys in your exams looking up at that and forgetting it. Come on, guys. This is one of the most used ones. If you have to learn one, learn this one. All right? So the displacement is 0. The initial vertical velocity is u sine alpha times by the time, which is 120 divided by u cos alpha, plus a half a. I'm going to multiply that out. So that's a half times minus 9.8 minus 49 over 10. Just multiply that. Times by t squared. 120 squared is 14,400 divided by u squared cos squared alpha. Are we happy with how I squared that there? Let me know any questions, all right? So I've just squared my time there. Don't worry about the obnoxious numbers because you can see we have a 588. We want big numbers. So now I am just going to move this onto this side and multiply out. So then I just get 12u sine alpha over u cos alpha on this part over here. Sorry, I made a mistake. Apologies. That is not 120. That is 12. So there's 12u sine alpha cos alpha, and this is on the other side. So that's just going to be equal to 70,560 divided by u squared cos squared alpha. So I've just done 49 over 10 times by that. It's on the other side, so it's positive, and that's equal. Now, what am I solving for? I'm solving for u squared cos alpha sine alpha. So let's see what I can do here. Here, my u's cancel. So that's one thing I can do. So if I multiply u squared cos squared alpha onto both sides, I want to bring all my cos alphas and trig and u's onto one side. So then I'm just going to get 12 sine alpha by cos alpha multiplied by u squared cos squared alpha is equal to 70,560. Now, I got a cos alpha down there, and I've got a cos squared alpha here, so that cancels with one of the cos alphas. So then I have 12 wait, what am I doing? Yep. So I've got 12u squared sine alpha cos alpha is equal to 70,560. So now look at this bit. This is exactly what I want. All I have to do is divide through by 12. Therefore, u squared sine alpha cos alpha is equal to this thing divided by 12, which gives me 5880, which is exactly what, sorry, why am I including zeros unnecessarily? Which gives me 588. I feel like I made a mistake somewhere. Nope, I know where I made the mistake. That's 120, that's meant to be 120, that's 120, hold on, I'm coming back. That's going to be 120, dividing by 120 there, which gives me that. Alright, that's also 120. I've corrected myself, I think. I'm going to see a bunch of comments in the chat about this, aren't I? Yeah, 120, guys. Yeah, I think I fixed it, right? See, I redeemed myself. Everyone makes mistakes. Just make sure you pick up on your mistakes. So imagine you are looking at me doing the working on my life. I make a little mistake and drop a 0. Make sure you pick up on that little mistake like I did here. Because I was like, something is not right. And then I looked at the comments and everyone else clocked it too. So that's good. I'm so glad you guys actually caught that. That's very good. I was testing you totally. So yeah, that is worth 6 marks. That is a pretty decent question. And almost, yeah, I'll be honest, every projectile question follows a similar structure. The structure is write down everything for your vertical motion. So pick how much of the motion you're doing. So this is for the entire motion. So this is all my vertical motion information. This is my horizontal motion information. Horizontal, you're just doing a speed, distance, time calculation with that. Vertical, you're doing a suvat calculation. Then for this, you just sub in, and now this is your chance. You need to somehow rearrange that to get u squared sine alpha cos alpha. That's what you do there. So I've just done what I could by multiplying out, simplifying, bringing all my u's and cos and sines onto one side, and then I get that. Does that make sense for this 6 marks? Does that help anyone who was previously struggling with projectiles? Can you explain why you got the how you got the t's? Yeah, sure. So horizontally, you've got a displacement, which is 120 meters. You've got a velocity horizontally of u cos alpha, and then you've got a time. In this question, they have not given me the time, but you can figure it out because remember, I told you horizontally is just a speed equals distance divided by time calculation. So time is equal to the distance divided by the speed, which is that horizontally. Now, imagine you are throwing a ball or hitting this golf ball in this motion. The time horizontally is also going to be the time it takes to go up there and come back down. So the vertical time is also going to be that. That's how. So the time is the same. Which one is 0 when the other is constant? Acceleration or velocity? Which one is 0? So when the velocity is constant, acceleration is 0. Amy, I think that's what you're trying to ask. Yeah, and Bryn answered. There you go. Awesome. So that's how you do part A. Any projectiles question, literally do what I've done in this top part of the page here. Then you can see what you need to do. This is like your little reference thing, like your little menu. Refer to that menu throughout this question. Let's move on. This is going to be like the last mathsy question we do on this live. The ball reaches a maximum height of 10 meters above the ground. Show, again, u squared is equal to 1,960. So glad you guys are understanding. No worries. So I'm going to just label that onto my diagram. So there is going to be, what is the maximum height? 10 meters. So that is going to be equal to 10 meters. So I need to show u squared. So what can I do? I can do my vertical motion, right? So for part B, my method, I'm not going to lie, is a bit long. I think there are quicker methods, but my method for me logically works. So hopefully for you guys, it logically works too. So if I'm doing just vertical motion and I'm taking upwards as positive, vertical, my displacement is going to be 10 meters because that's what they told me there's a maximum height. My initial velocity is still going to be u sine alpha. But like I said, remember, if it's at its maximum height, the final velocity is going to be equal to 0. Because you launch something, it temporarily stops before it changes direction, right? The acceleration is downwards, so it's going to be negative 9.8 meters per second squared. And the time, well, the time for this one is going to be half the time it takes for the entire motion. So the time it takes for the entire motion, we said down here, is 120 u cos alpha. So the time it takes for half the motion is going to be half of that. So that's 60 over u cos alpha. Now, I need to have an equation with u squared in it. I want to use the fact that s is 10 and v is 0, because if I have a 0 in my equation, it makes it quite nice, and they've given me this information, so I kind of want to use that. So if I have an equation linking these variables, I get v squared equals u squared plus 2as. I like the fact that I'm seeing a u squared because the question wants me to find u squared. So v squared is just 0 equals u squared sine squared alpha plus 2as is minus 19.6 times by 10. That's 2 times minus 9.8 times by 10. And if I rearrange, I get u squared sine squared alpha is equal to 196. So u sine alpha is equal to 14. All right, so I've got u sine alpha, but what do I actually want to find? I want to find u squared equals 1,960. So I've got two unknowns, and I've said this in all my lives. I'm going to say it again. If you have two unknowns, which is u and alpha, you need two equations. So I'm going to make another equation using these variables. So I'm going to do s equals, oh no, it's gone away. Okay, so you know what I'm going to do? I'm going to go to my solutions bit, and we're going to go down as if nothing happened. So I'm going to do s equals vt minus half AT squared. Yeah, not again. But yeah, don't worry, this is identical to it. Ignore the mistakes I've made up here. So you can see where I made mistakes. So S equals VT minus half AT squared. I'm going to check out GoodNotes straight after while I'm uploading the live. So, oh, I'm glad I'm not the only one. Keanu also gets it too. So S is equal to 10 and VT, well, V is 0. So that's just plus a half times by a negative negative make a plus. That's 49 over 10. T squared is just going to be that. So then if I just evaluate this bit over here, I get this, which is 17,640 over u squared cos squared alpha. If I rearrange, I get u squared cos squared alpha is this thing divided by 10, which is 1,764. So u cos alpha is 42. So this so far, where you see the green ticks, that gives you 3 marks. You get 1 mark for this, you get 1 mark for this, you get 1 mark for this. Not many marks in my opinion. So now I need to find alpha to put back into my equation. So if I just do sine, if you see a sine and a cos, you're going to want to find the tan. So sine alpha by cos alpha, dividing equation 1 by 2, you get tan alpha, the u's cancel, 14 over 12. So alpha is inverse tan of 14 over 12, which is 1/3, which is equal to 18.43, and so on. I have stored that as A. The way you store something in your calculator is you see your calculator here. It is very dark. Let me just turn on a light. All right, cool. There's some light. You see your calculator here? You click that store button. So if I go, I want to store 99, so I press store, A. See, answer has gone to A. That's how you do that. So I've stored this angle as A. So now I'm just going to go back up to this equation which I've used before, the equation from part A, because somehow I need to use that result, right? So u squared sine alpha cos alpha, I know what alpha is now, so I can just plug that in. So if I do that and rearrange for u squared, I get 588 divided by sine alpha, which is 18.43, times by cos alpha, which is that, is equal to 1,960, and boom, we have proved part B of the question. Does that make sense, guys? That one was longer and much more weird than part A. But yeah, I can't wait to bid on my favorites. Honestly, the satisfaction of getting rid of them and closing all the tabs on Google. Oof, there were so many tabs open. Such a mess. I'm gonna burn mine in a wood fire. Oh my god. Could you show part B working out? Sure. This is all the working for part B. So for part B, I don't really know what I'm doing. Yeah, all that for 4 marks. I'm sure there are quicker ways. This is just the way that I did it logically. So I'm going to quickly explain it so you can see all the important information is on this page. So for part A, I have u squared sine alpha cos alpha is that. They want me to find what u squared is equal to. So if I find what alpha is, I can easily just sub in and rearrange. So taking upwards motion, they told me the maximum height is 10. The final velocity would be 0. I know these values from before. The time now is half the time taken before. So that's 60 over u cos alpha. So I want to make an equation out of this, which involves u squared in it. So I want to use that. I like the number 0, so I'm going to pick that too. And they've given me this fact, so I'm going to use that fact too, because this looks kind of ugly. So v squared equals u squared plus 2as, stub in and rearrange for u sine alpha. Okay, I've still got 2 unknowns, so 2 unknowns means 2 equations. So I'm going to make another equation with this. This time I'm going to use variables I haven't used yet, so t. So then s equals vt minus a half at squared. Because v is 0, I want to have as little working as I can to do. So that's 10 equals minus a half times minus 9.8 is minus 49 over 10. And then t squared is this thing here. If I multiply that out, I get that. If I multiply u squared cos squared alpha across and divide through by 10, I get this. So square root both sides, you get that. So now I've got sine alpha and cos alpha. What did I want to find? I wanted to find alpha, right? To sub in there. Or I could just rearrange and sub in. So then I get that tan alpha is 14 by 2 by just dividing. Remember, if you see a sine and a cos, divide them to find tan, and then you can solve for alpha. So that's 14 over 42. You find your angle is that. So going back to this equation, I can sub in my alpha, which I've just found, rearrange, and I get 1,960. Does that make sense? You can watch my live replay on my YouTube, which I'll post as soon as I can. That is that. Wow, this live has been going on for over 3 hours. That's crazy. All right, last 2 questions. You would do this working in degrees because Does it say? Well, it doesn't. It just says angle A. But why would you want to work in radians? This one, whenever you're doing this, work in degrees. Okay. For stats and mechanics, only work in radians if you're doing thingy, if you're doing integration or differentiation. But yeah, with projectiles questions, don't make it hard. If you like working in radians, then go for it. But I would just stick to degrees. That's so much easier. 12 marker at the end is crazy. It's crazy, but it is expected. The last question is going to be most likely the bigger question. It was in my papers. It was in every other paper. Probably going to be in your paper. Now, you and I are just going to do a bit of talking. So that was the last bit of maths on this slide. We're doing some talking now. These are the one markers which people tend to not like, but I'm going to show you how to like them. So, in a refinement to the model, the effect of air resistance is included. So, air resistance is included this time. The motion of the ball from A to B is now modeled as that of a particle whose initial speed is v meters per second. This is the 2022 paper. Degrees, I find degrees easier because I've used it more of my life. But yeah, degrees is just, yeah, this was a nice 6 marks. Projectiles are nice. Yeah, if you like using radians, go for it. Personally, I would advise against it, but yeah. So, state which is greater, U or V. Give a reason for your answer. The thing you need to notice is it is still going from A to B. It is still moving from A to B. With that speed, it needs to cover this distance. However, there's going to be air resistance. So, tell me in the chat, guys, which value is greater? Is U greater or is V greater? I use SUVAT for data time graph. Yes, you can use SUVAT for velocity time graphs, and if required. Predicted topics, I'll tell at the end what I think generally. I'm seeing V, I'm seeing U. Think about it. If I want to cover the same distance, but now I am including air resistance, the speed V and U both get this to move the same distance. I took a nap, woke up, and you're still going. Yeah, this is dedication right here. So, I'm seeing a mix of answers. So I'm going to explain it to you, and we're going to logic it through. I'm going to tell you the answer first, and we'll see why. So, yeah, it says it covers the same distance, so it's V, 100%. This will be up on YouTube as soon. It depends on YouTube, I'll be honest. As soon as this is done, I'm going to start working on exporting it. I will update on my TikTok when it's up. So, I'm going to do it as soon as I can. Hopefully by today, I'm going to stay up until it's up, even if I stay up till 1 a.m. for you guys. I want you guys to see this in case you need it. So, the reason that V is greater is because you see the question says, this is where the question is being sneaky. Notice I've underlined this. It is moving. This is the last question. This is the very last question we're doing for my live. So notice that the question is telling us the ball is moving from A to B. So it is still needing to move that same distance. With the speed of U, there is no air resistance. However, with V, I have air resistance now, but V is still making it do that same distance. So if V needs to overcome air resistance, V is going to be bigger. So the answer I wrote formally, which will get you the marks, is V. And look, I left a little gap, so it's quite clear. So V, because air resistance has to be overcome to reach the same distance. That is what you do. It has to travel faster to go the same resistance as air resistance opposes the forces of the speed. Exactly, Brent. That is perfect explanation. So do you guys see why you need to read the question very, very carefully? Because they want you to cover the same distance. So yeah, 3 hours on a 2-hour paper. Yeah, it's because I'm explaining stuff, right? And going over stuff again. It is expected. Can you recap the 4 marker, please? I'm going to do that very, very quickly, okay? Check my live replay if you want. So for the 4 marker, I need to find U squared, right? So if I just sub in alpha into this, I can find what U squared is. So I'm going to find what alpha is. I've been given information about the vertical height, so I'm going to use my vertical motion. So put in my values there, come up with an equation for that, which has a U and a sine alpha in. So I have a sine alpha. I have 2 unknowns, so I need 2 equations. So I'm going to make another one where I find cos alpha. Sine alpha and cos alpha, you straight away think tan alpha, right? So you divide this by this, so then you get tan alpha as that. You find alpha, your angle. You plug that into this equation here, rearrange, and you get your answer. I have a more detailed walkthrough in my live replay. Do not worry. So that is how you do part C. Does part C make sense now, guys? Do you see why you need to read the question very carefully if it's covering the same distance? All right. So last part, last bit of my live for this season. State one further refinement to the model that would make it more realistic. Guys, this is a free for all. Everyone go. Tell me one further refinement. I'm going to go back to the question. Tell me one further refinement for this model. Spin. Exactly. I knew Bryn would say spin. Spin, spin, spin. That is one. What is another refinement you guys could make? And notice it's one further refinement. You need to not say something. Do not say this value because yes, air. Oh, no, 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 no. Air resistance is now accounted for. But that's exactly what I was saying, Harman power. So look at this. In a refinement to the model, the effect of air resistance is included. State one, further refinement. Further refinement means not this, because they refined it a bit. Now you want to refine it even more. That is what a further refinement is. No worries, Harman Power. So, sorry if I'm saying your name wrong, Harman Panwar. Sorry. So, a further refinement is the one that's not been included already. They have included air resistance in their first refinement, so you are not including it in your further one. I'm seeing other things. I'm seeing more accurate G. Exactly, use a more accurate value of G. You have the spin. Guys, tell me anything else. Got a few people in this live. Come on, just type in something. Ba, 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 ba. Think about it. You are modeling it as a particle. It's moving freely under gravity. It is a golf ball. Spinny Winnie, yes, spin. So easy to remember. Just that is your four-letter answer, like you said yesterday. Wind, exactly. The effects of wind will blow it off its course potentially. Yeah. So the answers that are allowed and not allowed are on the screen now. Consider the effects of wind. Use a more accurate value of G. Spin, size, shape, or dimensions of the ball, or the ball is not a particle. Variable acceleration. You can use spin every time. Just look at the context of the question. If it's modeled as a particle, then you're all good. It's about the surface area of the ball and humidity. Because this question is about a golf ball being hit above the ground, you're outdoors, so you could consider humidity. I would stay away from that because I've only seen that in the mark scheme once for this question. And then they tell you to ignore air resistance in the mark scheme. Why? Because it has already been included as an initial refinement. They want a further refinement. You can write just one word, spin. Say what is of those. Say spin of the ball. Okay? Don't just say spin, just in case they're harsh. Say spin of the ball. So you can say, let me just say that one more time. You can say the effects of wind, more accurate value for G equals 9.81, or so on. Spin, size, shape, or dimension, or surface area of the ball using a variable acceleration. Modeling the ball not as a particle. Do not say humidity is an answer, but don't say it. That's just weird to put. And you are not allowed to put air resistance. So if not said, then the go-to is air resistance. Yup. Yup. So you can say air resistance if they don't say it. If they didn't include this line here and we didn't have part C, then you can say air resistance, that would be allowed. So yeah, so spin. You can't just say spin on its own. I like to be safe and say spin up the ball. That's just me because I get very, very paranoid with my answers sometimes. So I write a ton. But yeah, that with this missing missing text there. So I can just write spin. Yeah, I'm going to show you the mark scheme for this question actually. Is this stats? That's stats. That's the mark scheme. This is what the mark scheme says. Wind effects, more accurate value of G. Spin of ball, size of ball, shape of ball, dimensions of ball, not a particle, variable acceleration, surface area of ball, humidity, allow wind resistance and rotational resistance. So yeah, spin if the ball is modeled as a particle. Yep, this is at Excel. You can write spin, but just put spin of ball just to be safe. Just to be safe. Go over hinges. All right. I'm gonna do one more question. Surprise question, then fine. We're gonna go over hinges. I do have a post, and I'm gonna go over the question I did in that post. So check out the TikTok on that afterwards. We're gonna do hinges, and then if you guys have any other like discussion-based questions, we'll do. Any advice you want, we'll do that. So I'm just gonna quickly put hinges on. So I'm gonna just block my screen while I get that question up. Give me 1 second. Get my little document. Okay, cool. So yeah, this is a bit of behind the scenes of how I make my videos. So this is the hinges video. I have a post on pivots. I do have a post on that. So all my mechanics videos are on this little thing. So let me tell you, these are the mechanics videos I have. This is kind of about pivots where you have moments. So pivots are to do with moments, I'm assuming, right? So there's a moments question with weird one there, a large data set question, a binomial distribution and conditions question, variable acceleration question, weird probability distribution question. This one actually went like quite well yesterday, actually, I saw. Dynamic and slopes question, and then projectiles with vectors question, because I haven't seen that come up in an exam and someone asked for it, so I made this video for them. And then today's video was about hinges, which I'm just going to run through one more time on this live. I gotta zoom out, and I think, yep, there's one more video hidden all the way here. A normal distribution hypothesis testing. So, I will tell you my predictions on math at Excel GCSE question with Pharma. Can I get full if I show? Always show working. Sometimes they will allow the correct answer, but that is very, very rarely. Sometimes it says no working is required to be shown, but yeah, that is in very rare cases, and you don't even know when that is. So just show all the working, just be safe, right? Just write down everything you are thinking on that page so the examiner sees, okay? So last question, which I'm going to walk through. I'm going to walk through it kind of fast because this is one of my TikToks, so do check that out. So I open my headquarters and hang a sign modeled as a uniform rod. The rod AB has mass 5 kg, length 4 meters, and is smoothly hinged. So this is my diagram. That's my rod, and that is my string, okay, where it tells me there. So it is a uniform rod, which means that the mass acts in the middle of it. So that's 5g is the weight. Sorry, the weight acts in the middle. So I've got 2 meters on either side. It is smoothly hinged. That means that at this hinge, I don't have friction, and there's a reaction force at a hinge. That reaction force is at an angle. I don't know what that angle is, so I'm just going to say that this reaction force has a horizontal and a vertical component like that. That is what you do when you get a hinges question. It is attached to a string. AC is 3, so I just labeled 3 and 1 there, and D is vertically above. It is in equilibrium. If that's keeping it in equilibrium, that tension is going that direction. And the angle is 30, so I've resolved my tension too because I want all my horizontal and vertical components. Calculate the tension. So I don't know forces at 2 points, at the hinge and at C, which is the tension. So I'm going to take moments. So taking moments about A, so I can forget about the reaction at the hinge. Sum of clockwise is equal to anti-clockwise. Force times perpendicular distances. Rearrange for T, and you get that. So then if you want to do part B, magnitude and direction, you need to think about the forces at the hinge. So I'm going to resolve vertically and horizontally because now I know all the other forces. I just don't know the forces at one point. So doing that, resolving vertically, I get V plus T sine 30, which is a vertical component of tension, is equal to the downwards weight. Get V as that. Horizontally, that is just that. I need the magnitude, so you have to do Pythagoras on both of them, and you get that. And the direction is at an angle, so I said is at 16.1 degrees to 3 significant figures above the rod AB. So it'll be acting in, I'm just going to show you, this sort of direction. That is the reaction at the hinge. So we didn't know that that was the angle, but we assumed that there's a horizontal and a vertical component to that reaction at the hinge, and that's how you do it. Check out my TikTok. I posted it today for a full explanation. Let me just check questions. Thank you all for sharing the live and for joining. This is A level. Just show all the working. The friction, let me see, has been, yep, at the hinge either up or down. So you would take the direction. If you got a negative answer, it's opposite to your drawing, like I said in the video. So yeah, if it was not smoothly hinged, you would have friction at that. Yeah, just show working. So now I'm going to tell you what my predictions are. So the videos I made are kind of semi like my predictions. Like I just did videos on main topics that will come up. So let me just cover my screen and go back to the exam question. All right, cool. So my predictions for stats, like I said, are just the main topics that appear. So I'm going to go through the textbooks and tell you what I think are the big topics. So from year 1, stats and mechanics, I feel like you may get a small little question about populations and sampling, and about you're going to get a few 1, 2, 3, or 4 marks about the large data set. So make sure you know about that. You're going to get a question about mean or ranges or variance. That's going to be a small one, nice, easy mark. You could get a question about interpolation, so make sure you practice that in the textbook. And coding. Coding might actually come up because it hasn't come up since I think 2022 or 2023. So maybe coding might come up. Coding is not too bad. Just know that when you're coding, how the mean and the standard, let me tell you what they are, how they changed. So the mean of the coded data is just the same as what the coding is, and the standard deviation is just any scalar thing, dividing or multiplying. I had that in my live from my stats live is on my YouTube channel. Yep, the SD doesn't change unless you are doing this. This is what it says. Standard deviation only changes if you enlarge it or like by dividing or multiplying it, so by b, because that just affects how long or wide it scale. So that's what else. Okay, you're gonna definitely get a question, and it's either gonna be box plots, cumulative frequency, or histograms, in my opinion. I don't think you're gonna get Venn diagrams because you got that last year. You could, but more likely I'd focus on those ones if you struggle with them. Make sure you're good with all of those, though, of course. There's going to be some sort of correlation question. Most likely it's going to be a year 2 type question. And probability, that is going to come up for sure. You need to know how to deal with probability distributions. Check out my XP gaming video question about probability distribution, weird problem solving logic ones. Those ones tend to trip most of us up. Statistical distributions, you're going to get binomial for sure. So make sure you love binomial and you're good with it. You know how to use the tables and the calculator. And hypothesis testing. That is going to come up in some shape or form. It's either going to be a binomial test, a normal test, or a PMCC test. Yeah, probability distributions are not the best thing. So you need to be able to do hypothesis tests with 2 ways: comparing your result with the significance level, or by finding the critical region and comparing your result within the critical region or not. One-tailed and two-tailed, that is definitely going to come up. Hypothesis testing is going to come up. CG50, that's the electronic calculator, right? That's the one with the screen, right? I don't have that. I managed to be just fine using this. I never know the conclusion. All right, the conclusion, check out my stats videos I do on hypothesis. If the probability of that event is less than the significance level, reject the null hypothesis, because that is basically telling that the chance of it being random is so small that it's not random, that there's actually a change, okay? If it's less than. If it's greater than the significance level, you cannot reject HO. So if it's low, reject HO. Remember like that if it helps. But then for critical region is the region where you criticize your result. If it falls in the critical region, you're criticizing it, then there's going to be a change. So you reject HO. That's how that works. With mechanics, you need to know your modeling assumptions for sure for those 1 markers. There's going to be a constant acceleration type question. It could be within a projectiles. Forces in motion, make sure you know how to do forces in motion. You could get a police question. I did that in my live yesterday. It's on my YouTube channel. Variable acceleration is definitely going to come up. So that means your equation has a t in it. With variable acceleration, you cannot do SUVAT. SUVAT is constant acceleration. So you differentiate and integrate. So that's my predictions and what I think is likely to come up from book 1. From year 2, if the P is low, HO gotta go. Exactly. Don't worry about tension. Tension is not too bad. The tension goes towards the pulley. Just resolve parallel and perpendicular to that. Okay? Now, I'm looking at the year 2 book. If you guys want to get out your year 2 books or that screen, the contents page, you most likely are going to have something to do with PMCC or exponential models and like linearizing them. That has come up. That is not too difficult if you know how to deal with logs and how to do that hypothesis test. That should be good marks. Conditional probability comes up, some shape or form. It could be hidden as part of a bigger question. Know the formula, the base formula, then apply that for more complex examples. You are going to definitely 100% going to get a normal distribution question. That is going to be a bigger question, and it could either be very easy where you just have to find inverse normal or just some normal probabilities, or they could have a very long-winded question like the ones we've done in our lives so far. Make sure you are happy with how the progression through the textbook chapters work, how you build up and what to do when. Just follow that. I'm looking at people saying, don't worry, I am reading through your comments as I'm talking. It is coming up. Moments I'm talking about, I'm going to mention that just now. So, moments comes up as part of applications of forces questions. I've very rarely seen a moments question just as is. So make sure you can do moments and use it within other forces. So that's linking chapter 4 and chapter 7. So make sure you know how to do resultant moments. What happens in equilibrium? The sum of moments is all equal. So let me just check. And then centers of mass, you need to know if it's uniform or not, where that acts. And with tilting, if it's on the point of tilting, then you're not going to have a reaction on that like seesaw-like shape. So make sure you know what tilting looks like. Tilting, I don't think tilting has come up for a while. You could get tilting, maybe, if they decide to assess that. So yeah, you could get anything, to be honest. I'm just saying what hasn't come up, and yeah. Forces and friction, that's all going to be part of a Unit 7 question. You're going to for sure have friction. Make sure you know how friction works. That friction is going to be increasing depending on the other motion. So friction will be increasing until a maximum value, right, guys? Bryn, thank you so much for the gifts. So friction will be increasing until it reaches a maximum. At that maximum, friction cannot increase, but your other forces can. Then you'd have an acceleration and a force in that direction. Projectiles. Oh, I pray if you guys love projectiles, I hope that comes up. Projectiles has come up all the time. Make sure you're good with that. Make sure you know how to do prove the formulas. The way you do it, don't memorize the proofs. Do what I did with projectiles. Do vertical and horizontal motions, and then see what equations you can make from there. See what equation your result looks like, and work backwards. Once you've written everything out, don't work backwards, but just see how am I going to get there. Thank you, Harman Panwar, for the gifts. I appreciate it. All right. Then applications of forces, that is going to be one of your big questions. Check out my TikToks for how to approach certain questions like that. Remember, you're going to basically just do two things there: moments and resolving. Moments if you don't know forces at 2 points, resolving if you don't know forces at one. And then further kinematics, you're most likely going to have a further kinematics question where you're going to differentiate or integrate with vectors. Make sure you're happy with that. Make sure you know to offset your R naught if it does not start at the origin for a vectors question. Make sure you're good with differentiating and integrating. Make sure you know how to differentiate and integrate your two like content. So differentiating and integrating trig or exponentials, product rule, chain rule, quotient rule, all of those, okay? So, and yeah, those are what I think is most likely to come up based on what's already come up. Obviously, don't gamble it. Make sure you're good with everything. Do practice. Practice is key. So yeah, do I recommend doing stats or mechanics first? Yep, whatever you're most comfortable with last. So yep, that's my predictions. Do you guys have any other general questions you want to ask about this? 2 years content in less than a day? Don't worry, it is doable, but you have to be smart with it. The way you have to do it is you have to see which topics are the biggest ones and the ones you struggle with most. You want to maximize your marks. Go through it, make sure you understand, see how it all comes together, then just do practice questions. Read the chapter summaries, do practice questions, see how they have done the mark schemes, and know the certain rules of thumb. For example, always define variables in statistics. Resolve forces vertically and horizontally or parallel and perpendicular to a slope with forces in motion. You have trig as well, yeah? So those are my rules of thumb. Look out for those nuances. It is possible. You got this, guys. 3.5 hour live for my last live of this season. I hope you guys enjoyed, actually. I hope you enjoyed my live. I hope you learned something. I hope it was helpful and eased your stress. I want you guys to go into that exam room tomorrow and ace that test. All right? No worries, guys. Please, I want to know from you guys how it was. Let me know, like, DM me after the exam. How was it? Looking forward to hearing your guys' thoughts on that. Awesome. Gonna have an A star. Let's go. Thank you, Amy, for that. I'm glad. But yeah, take care, guys. Thank you, Arman. I'm glad the concepts were clear for you. All right. Best of luck, Dada. Best of luck, everyone, with your exams. And yeah, I'm gonna post this on my YouTube channel as soon as I can. All right. Take care. Bye bye, guys.